I can start and then bring you in. Good morning. Good morning, Combermere. Good morning, Combermerians. Good morning, Barbados. Good morning, Barbadians. Good morning, Caribbean. Good morning, all persons in the diaspora, Barbadians, Combermere. Welcome, welcome, welcome to Combermere School's International Day of Mathematics 2025. Good morning again. This is an exciting day for us. March 14th, 2025, International Day of Mathematics. In the studio with me this morning is, of course, my very, very good friend, Mr. Michael Small, Head of Department of Physical Education, and unrepentant, unabashed, unashamed Combermerean to the core. Hello, Michael. How are you this morning?
Good morning, David. I am fine. It's nice to be here. I remember doing this 2 years ago.
2 years? I don't know where the time is gone, Michael.
And we had a good time.
Very good time.
I could expect that today will follow suit.
Of course.
I am pretty sure that the team that has put this together will maintain the standard that they set in 2023.
Yes.
And I'm eagerly looking forward to see what unfolds as the day goes by.
Wonderful. Excellent, excellent. As a matter of fact, behind the scenes, they have been just working like elves, not gremlins, elves, and working really, really hard. And of course, they are also teachers, and they have a daily duty of teaching and looking after our nation's children. So this has been a real mammoth task, but I congratulate all of them for putting it together. And Michael, at this introduction, I want you to indulge me for a couple of minutes, please, sir. I know you are Mr. Combermere, and I am an old scholar, but I have been invited back into your home, so I gotta use some of that privilege now. And I promise not to embarrass you, Michael. How long have you been associated with Combermere School?
Oh, Lord, man.
I know.
I don't think we need to bore people with details like that.
But plenty years.
But enough years.
Right.
A lot of years.
Michael, I think, in my opinion, that you are on course to be the iconic face of Combermere School. And let me tell you why. Every single time I come to this school, I see you. You come to this school religiously every day and look after our nation's children. And you are as exuberant as the day you first joined this teaching staff, or the day you first came. How do you keep it up? How do you love what you do so much, Michael, that you could actually exude Combermere every single day? How do you do it?
I cannot give you an exact answer to that. What I can tell you is that I've been surrounded with some great people at Combermere to work with. I mean, like my department, but there are people outside of my department that may come in here on a daily basis, an enjoyable task. And it's just a love for the school, as I like to describe myself as an unapologetic Combermerean. But I don't really want to focus on Michael Small because it's not about Michael Small.
I promise you, it's only 2 minutes, and after this,
it's not about Michael Small. It's about IDM, International Day of Mathematics.
That's correct. That is correct.
What I like about the production today is that we have members of other departments who have combined to make this a successful day.
Absolutely.
And as I said in our opening, I am pretty confident that we will have a very exciting day, a very informative day, a day that Combermerians can be proud of.
Thank you, Michael. And I mean, I am telling you, Michael, I come here to this school, I see you, and I am actually so proud to be Combermerian because of people like you. And let me give you a brief history here. Let me just recap what we would have done some years before. Combermere School has a very rich history. It spans over 330 years. And here are a few tidbits of information for you. Combermere School first hosted Mathematics Day on Tuesday, the 19th of March 2019. Mr. Radford de Pisa of the University of Waterloo International Outreach Program conducted a series of problem-solving workshops with groups of students from various year levels. The goal then, and it is now, for students to think outside the box, appreciate the practicality of mathematics as it applies to daily lives. March 14th, previously celebrated as Pi Day, and that is P-I and not P-I-E. Pi Day is a mathematics term, is now also celebrated as International Day of Mathematics, IDM. IDM. And the proclamation of March 14th as IDM was then adopted by UNESCO's Executive Council in the 205th session, and they adopted it on the 40th session of the General Conference of UNESCO. So this is an international day of recognition for mathematics and how mathematics applies to daily lives. Subsequently, the first celebration of International Mathematics Day was held March 14th, 2020, with the theme, Mathematics is Everywhere. Mathematics is everywhere. The International Day of Mathematics is a project led by the International Mathematics Union. So that's a brief history. I'll give you a little more tidbits as we go to and fro from the studio. But right now, we're going to have a video done by Mr. N. Pemberton. So I'm going to toss it back over.
Miss N. Pemberton.
Miss N. Pemberton, I beg your pardon. I'm going to toss it back over to John, who's in control of the things, and he'll have that interview queued up for you.
I'm a math student. Of course I know what are 8 lines. I'm a math student. Of course I know the Pythagoras theorem.
I'm a math student. Of course I love problems.
I'm a math student. Of course I use algebra in my everyday life.
I'm a math student. Of course I know 100 digits of pi. 3.141.9, this is pi.
I'm a math student. Of course I love calculus.
I'm a math teacher. Of course I'm always at work.
We're in junior school. Of course we love math.
Thank you. Back in the studio now. Michael, as you alluded to earlier, we have a number of departments collaborating, like the geography department will also collaborate with the sociology department, and chemistry, and chemistry will also be participating. This is a new innovation for us this year, isn't it?
Well, I guess so. I think the idea behind it was to get as many people involved in it, because I think that a lot of Barbadians had a fear of math.
Right.
And I think the concept of International Day of Mathematics is to let people understand that there's no need to be scared of maths. Mm-hmm. So you have the different departments, because whatever we do in teaching involves maths.
Right.
Whatever,
Right.
I mean in PE, I may ask the guys to prepare the cricket pitch. The cricket pitch is 22 yards. So you have to be able to read the tape to have the 22 yards.
Simple as that.
Right?
Yes.
Yes, as simple as that. So there are a lot of things in the other subject areas that embrace mathematics on a daily basis.
Correct.
So I think that this whole idea behind this today, as I said, is to let people understand math is something we use every day of our lives.
Very good, excellent. Just a little more history here involved. Combermere School, when they got the invitation in 2022 from the Ministry of Education, Technological and Vocational Training, which is now transformed into the Ministry of Educational Transformation, they undertook to join the ministry and its commitment to celebrate International Day of Mathematics on March 14, 2022. This was an excellent opportunity to get back on course, given the impact of COVID-19, because that really set the cat among the pigeons there, and education was really set back. We had to transform into online learning and hybrid learning, and that was a real test of the character of the school and Barbadians on the whole. So Combermere School's celebration was a small but successful one, confined most of the activities during math classes on that day. This year, the activities will be expanded and include many persons. For instance, we just described that the geography and the sociology department will be combining. We have chemistry, and I hear that we're going to be probably making things like soaps. I hear we're going to make some kites and fly them as well.
Yeah, I heard so. I that.
Wonderful, wonderful. In biology and the industrial arts department will also be collaborating with us on International Day of Mathematics. But right now, we are going to have a video on the truth tables by Duran Coward Calendar. So I'm going to toss it back to John in the control room, and we have that video by Duran Coward Calendar.
We're here with Duran Coward Calendar, student of Form 3B, who entered the video competition with a video on truth tables for the International Day of Mathematics. Duran, why did you choose to enter the competition this year?
I chose to enter the competition because I had entered in the first summer and I got third runner-up, so I decided that I would want to do it again because I enjoyed it in the first summer and want to see if I could place higher.
Okay, you persevered. I love that. Why did you choose this topic, truth tables?
I went into electronics and realized how easy it was, so I decided that I would share how easy it was.
Okay, so something you learned in electronics had a link with mathematics.
Yeah.
What are your favorite subjects at school?
Mainly art and math.
Why is that?
I enjoy art in general, and I like math because of the trial and error, just to see where to place your footing so you can go for it, I guess.
Okay.
So at the end of the day, the theme for this year deals with both art, math, and creativity. Mm-hmm. What inspired your creativity in this particular video? What was your inspiration?
Nothing really. I just knew that I wanted to enter and realizing how easy the truth tables were. I said, okay, I'll just do math video on it, and just kind of thought it was great.
Is that your voice you heard in the video? Did you use your own voice or did you use computer-generated voices?
I used computer-generated voices for most of it, but for the computer that spoke, I had
that was you.
Yeah.
Okay, good.
Can you hear the similarity?
Yes, definitely. So, Duran, ultimately, where do you want this to take you? So, you have you're in third form, you're about to make your choices in terms of subjects and options. Where do you see your career path?
I plan to be an engineer and an animator.
Ooh, awesome. So you already started that?
Yes.
By doing this video?
Yes, please.
Okay, great. So we're having a chat with you about your truth tables video, and it looks awesome. So let's wait and see what the results will be at the end of the day. Thank you so much, Duran, for being here with us.
Thank you for having me.
And we wish you well. We wish you well.
Thank you.
Thank you, Duran.
Stocks are going strong. I think that's enough. Oh, hello. Hola. Bonjour. As you can see by my humble abode, I am quite rich. In fact, I made all electronics in this place. You might be asking how. Well, after learning Boolean algebra in university, I learned how to build electronics, like this TV, for example. I'm here to teach you how it applies to everyday life. I'll hand it off to a friend to tell you about it.
Hello, how are ya? So the long and short of Boolean algebra is binary numbers, 1 meaning true and 0 meaning false. I'll leave it to my friend Brain to explain more.
Greetings, all sentient organisms from the planet Earth. I, your father's network, to educate you on how truth tables work. Truth tables prove that circles will work or not using binary code, which is how I was created. I will show you an example so you can visualize how it is calculated. You input the number shown into the equation. The exclamation marks after one of the things used in your alphabet indicates is the opposite. Therefore, in the first one, 0 times 0 plus 1 plus 1 times 0 would equal to 1, making it true. That's all from me. Farewell.
But you might be questioning, how does this apply to everyday life? Well, it's fundamental in digital electronics. From cellular phones to brain to logic gates like and, or, not, and XOR, which can make arcade games, to the car you came to school in this morning. Without Boolean algebra, all of the technology that makes our lives so simple wouldn't have existed. Wait, what time is it? Oh shoot, I have to go. But that's about it until next time. Goodbye.
Thank you. And once again, let me acknowledge the tremendous work done by the coordinators of this program and the persons in the technical department working behind the scenes for this program. Michael, who do we have up next?
Oh, we have an interview with Kira Bourne. That's up next.
Right.
A video interview with her.
Right, okay. So we could jump right into that. We can have this recorded interview with Kira Bourne.
We want to welcome Kira Bourne of Form 4F, who has particular interest in robotics. I can't wait to hear what Kira is going to share with us today. Kira has collaborated with teammates to build robots during a summer robotics camp and continues to feed her passion of building robots on her own, supported by her parents, who ensure that she has the kits online.
Kira, how did this journey with robotics begin?
It started last summer, particularly it started last summer at the UE's camp BJRC. When my mother had enrolled me, I got permission from the teachers at school. I think it was Miss Molino who signed the paper to let me go. And we were given the basics of how to do programming and building a robot, which would prepare us for the final showcase at the end of camp, which is where we'll show off all our robots. So that's where we started.
Okay, so could you tell me then about the robot that you built for your showcase?
I built a robot and her name was Frankie. And Frankie's name came from the fact that she was two robots just kind of smashed into one. And she was meant to be obstacle avoiding, and her purpose was to help search and rescue teams.
Okay, that's interesting. And was that a smooth process, smashing the two robots together to make this Frankie robot?
No, most definitely not. When we first put her together, the wheels were falling off because we couldn't get it secured properly. And then once we did get it secured properly, it was tilting to one side. And so one side we had to put significantly more power to, and that was draining the batteries and so on and so forth.
Okay. So it really sounds like you had to use lots of problem-solving skills in preparing your robot. what other skills would you say you need, what subjects you need to be aware of to be into robotics?
I think I have to have a general understanding of code itself. You could learn it or you could just get it naturally.
Okay.
But as for the subjects part of it, you probably need things like physics and mathematics, as well as IT, of course. You'd need to know how to do pseudocode, and you'd also need to know how to work the components and put them together. So maybe electronics.
Okay.
All right. So it also sounds like you need some programming. What in particular is the programming language that you were using? Can you share some more about that? How easy was that to learn? Was it difficult? Was it hard? How did you feel?
It depended on what aspect of the coding language I was learning. So I was using Arduino, which is C++, and Arduino has its own app that immediately syncs to its boards. So it was easier to get the code onto the robot. So we didn't really have any issues there with actually uploading the code. It was getting the code to work itself. So like, when we were first building things, I had built an alarm system and I didn't have the correct board selected, so that was something you had to make sure because there are multiple Arduino boards. So that's one of the things. For the coding aspect, it's pretty easy to learn once you know what you're doing. So if you understand it, you could learn it easily, but the other aspects are harder.
And because you're taking IT at school, did that make it a little bit easier than some of the others? You find?
Yeah, it definitely helped. With learning the pseudocode at school, that helped me a lot because I then knew how to do the basics before I could write it.
So in terms of mathematics, what role do you think mathematics plays when it comes to robotics?
It could play a role in two different aspects, the design process and the coding process. So for the design process, if you wanted to make a custom base for your robot, you need to measure out how wide your components are, how long they are, how tall they are, different things to make your robotic base, to make the insides of your robot large enough. Another thing you'd have to do is like calculate weight. If your robot was too heavy on one side, it would topple over, or you need more speed in the motors to make your robot to move forward. As for the coding aspect, if you were to have something like a distance sensor, sometimes your sensor could be broken / off, and you might need to enter it manually what like 5 units is 1 centimeter, or how the sensor might have 5 centimeters is actually 7 centimeters. So that when you're putting it into the code, it'll actually drive the correct distance or stop the correct distance away.
Okay, fair enough. Do you see any improvements in FrankieBot? Do you think that she can improve?
Yeah, FrankieBot can definitely improve.
Okay.
Definitely improve. She only turns one direction. That was because we couldn't figure out how to get her to register and turn a second direction. If we had more time, I think we would have been able to do it, but we didn't. So what we had done is that she'll turn a 90-degree angle the first time, and I think we had her turn right. So she'll turn right at a 90-degree angle the first time, and to prevent her from going the way she came, she would then turn a 180-degree angle and hopefully continue upwards.
So I do remember you talking about the programming language, but I want to know, because all programmers experience this, did your program crash at any point in time?
Oh yeah, the programming language wasn't that compatible with my laptop at certain times. I think that was just my laptop wanting to cause me trouble, if you ask me personally.
Okay.
But yeah, it would crash sometimes, and sometimes it wouldn't upload, and other times it wouldn't save. So then like, you might have tinkered the smallest thing, and that wouldn't have saved, and then all of a sudden something's not working.
And you thought you fixed it.
Yeah, you thought you fixed the problem. You didn't.
Okay. So where do you see robotics taking us in the next 5 years, 10 years?
If enough attention is given to it, I'm going to use the example I used at camp, it would be easier for search and rescue teams if they had smaller robots that could go into tighter spaces. This will help so that the search and rescue teams will know exactly where people are. So if you were to like put a thermal camera on it and you were looking for a victim in a collapsed building, you'd be able to find it easier versus human search and rescue, which takes a longer time because this robot should be able to go in tighter spaces.
Okay.
All right.
All right, thank you for chatting with us, Kira. It was interesting to hear about your journey with the robotics. And we hope to see more from you.
Thank you.
Our cheese is wrapped in black and gold. It is called by name, proper cheese. Cheese, dumb bread. You hear what I say? The best cheese is proper cheese. Now 15% off. Ask for the proper cheese at A1 Supermarkets, Carlton and Emerald City.
Emerald City and Carlton.
Proper.
Samantha's a florist. She works day and night. And this year, she got a new four-wheel drive. But life is uncertain and roads can be tough. And one day her route home was not long enough. Then along came a promise of fortune to change, fast, fair claim settlement, and service that saves. So Samantha, now revved up with answers in tow, can look to the future with worry no more. CGI is here. Let's work it out. Samantha's a florist. She works day and night. And this year, she got a new four-wheel drive. But life is uncertain and roads can be tough. And one day her route home was not long enough. Then along came a promise of fortune to change, fast, fair claim settlement, and service that saves. So Samantha, now revved up with answers in tow, can look to the future with worry no more. CGI is here. Let's work it out.
And we are back live in these beautiful studios here at the University of Waterford campus, also known as the Combermere School. I'd like to remind all our viewers that today is Friday. It is a school day. And there's teaching going on and there are classes going on. And just now during one of the interviews, the iconic bell rang. And I turned to Michael and said that when that bell is retired, we have decided we could put it on a pedestal about a mile high so nobody can reach it, because that bell was with us. And I promise not to embarrass Michael anymore, so I'm not going to ask him any more questions about how long he's been associated at the school. But I entered the school in 1966, and that bell has been ringing since then. So you know my attachment to that. So Michael, I promise, I stick to my promise. I don't want to know when you entered school. I just embarrassed myself. Does that hurt you?
I am listening to you.
Like, Michael, no mathematics today or nothing to relate it to mathematics at Combermere School could ever be complete without the mention of people like Jack Adams, the legendary Jack
yes.
Adams.
The playing field, the small playing field is actually named after him.
Right.
Along with being a math teacher, I think he was the person that introduced hockey to Combermere and by extension Barbados, right?
That's correct.
So Jack Adams, the contribution of Jack Adams is in no way minuscule. It is gigantic. And we have been blessed to have a lot of great mathematics teachers at Combermere. One that springs to my mind readily would have been the late Harry Seeley. And when I went to school here, Harry Seeley would have been the master in charge of the junior school.
That's right.
A man that had a way of just reaching out to students. You know, Harry Seeley was a remarkable man, a genteel person.
That's correct.
A mathematics wizard.
I see him in front of me right now.
You know, and I think that one of the things that Combermere has had over the years is a very caring staff. Staff that go out of their way to make the children happy in the school, take care of them. And that is something that was alive when I was at school as a student, and it continues to this day in 2025.
That's wonderful. That's wonderful. I mean, I too remember the late Harry Seeley and the late Jack Adams. Jack Adams, a wiry Irishman.
Yes, I heard about that.
Starched white pants that the seams would cut you. Fingers full of chalk and a T-square marching up and down, because he was a military man, the corridors, and instilling that level of respect from anyone. Harry Seeley's approach was different.
Yes.
Harry was genteel. You gave Harry respect because you knew it was due to Harry.
Yes.
And I recall hearing some of my contemporaries emerge from one of Harry's math classes and saying how much they enjoyed it and how they want Harry. And I was a little upset because he wasn't my teacher. You know, I remember what Harry would have done for a lot of countless numbers of young students at Combermere School. This is wonderful. Just a little more history as we go on to talk about Jack. And the commercial you just saw from Carlton and A1 Supermarket is also coming from an unrepentant Combermerean by the name of Mr. Andrew Bino. And Andrew Bino is a protege of the late Jack Adams.
Yes.
In fact,
yes.
Andrew Bino is the one who contributes to the Jack Adams Award every year. In 2009, the first ever Jack Adams Prize for outstanding performances in mathematics was awarded to Satira Marshall. This prize continues to be awarded on an annual basis to students who display exceptional ability in mathematics and is donated by the same Andrew Bino of A1 Supermarkets. This is a wonderful legacy that we will continue going forward. I want to jump ahead now, Mike, if you don't mind, we can jump ahead to an interview by Caitlin Jones. So let's cue that up and have that come to you right now. Interview with Caitlin Jones.
All right, today we are having a chat with Caitlin Jones, a sixth form student at Combermere School, studying pure mathematics, computer science, and geography. Caitlin is also the vice president of Creative Visual Arts Club. She entered the Math Day poster competition with a poster entitled, Did You Know? Caitlin, why did you decide to enter the competition?
I wanted to showcase how art and math would really combine. Since I already do pure math and I already do art, I thought it would be fun to just, enter the competition and show what I could do with both of the concepts. So.
Okay. Caitlin, what was your thought process? What was it like coming up with the idea behind this poster?
Well, because the theme was math and work, I wanted to showcase how many careers use math, because many careers do use math. So on my poster on the left, I have two accountants talking to each other, and one of them is asking the other one what the accounting formula is, and they reply with the accounting formula. So I wanted to show that accountants use math daily, right? They use math all the time. And on the right, I have a plane landing, right? And I have a right angle triangle. So I'm basically showing how trigonometry is used all the time to land the plane. So that was the right side. And then on the bottom, I have a family going for a checkup with their child, and the doctor is prescribing the medication. And I wanted to show how pediatricians especially, and most medical doctors, have to use formulas to get the right dosage for a child. So I was basically showing different career choices that would use math, which is, a lot of them. And that's why I said it was Did You Know? Because I feel like a lot of people don't know how many careers actually do use math. So
you are absolutely correct.
Yeah.
When I looked at your poster, I was very impressed with especially the one about the pediatrician. Yeah. I didn't know that was something that they had to do.
Yeah.
So going with the theme, math, art, and creativity, I really see how you brought this forward. Could you tell me, how did you start with your sketches and then the development of the idea to what we see now?
Right. So the first sketch I made, while I was at school, actually, I was on my iPad and I just thought of a few ideas. The first idea I came up with was having a teacher, pointing at the board and teaching math. But I kind of scrapped that idea. And I had people doing chemistry and using math as well. But then when I thought about chemistry, I thought, oh, medicine, and then I got to pediatricians and stuff like that. So that's how I did that. So I started with the sketch first, and then I went to Procreate, and I started like coloring it in and everything. And when you see like the cloud bubbles and stuff on the poster, that was added like a little bit after, because I wanted to really emphasize like what I was talking about, because like I wanted to put did you know in the middle and stuff like that. So that was really like the final thing that I did. Right. So that's what.
Okay, awesome. Thank you.
How would you say that math and your creativity intersect outside of creating the poster for Math Day?
Well, I feel like you kind of have to think like creatively to do math in the first place. Like you have to think outside the box. So I feel like I kind of apply that to the math that I do, like when I go to pure math. So yeah, I feel like that's how it applies. Yeah.
And does math apply to your art as well?
Sometimes, because when you're like making a drawing, you have to really think about, like, if you're making a poster or something specific like that, you have to think about the measurements that you would use, the canvas size that you would use, like all of those things. Like they do matter. So I think that yeah, when you're doing art, you have to think about math sometimes, at least sometimes. Like the amount of pixels that you would use, like stuff like that. So yeah.
Okay.
I can really hear your passion for mathematics and art. Do you have any idea, Caitlin, where your career path or what career path you're going to go down?
Well, I plan on doing computer science actually. Like I plan on doing cybersecurity, but studying computer science. But I will still do like art as a hobby most of the time. But I feel like I'm probably gonna have to use more math when I do those career paths. So it's better to start now and figure out.
Thank you.
Caitlin, it was good chatting with you. We really did appreciate your poster and this talk. And thank you for participating in International Day of Mathematics 2025.
Thank you so much, ma'am. It was nice talking to both of you.
No problem.
Welcome back to the studio, and another big shout out to all those hands on deck, all those members of staff, faculty who would have put this wonderful, intense program together. Michael, you be the thick of things, boy. Just give me a hint as to how intense this program was to get together.
Put it together, youuld have had some stressful periods.
That's an understatement, my friend.
But as I said to somebody years ago, one of the things I like about Combermere, the Combermere staff, a staff with diverse talents. They readily come together to make sure something like this is successful. Yeah. And that has been the hallmark of the staff of Combermere for years. I mean, you can see as you said, we have the geography department, sociology, chemistry. We have everybody is doing their part to make sure today will be a success. And not just a success, a resounding success.
Excellent.
A Combermere success.
Yeah. From the University of Waterford. We got things like a worry competition. Now that is mathematics. Give me that. All African game, a worry competition, and they're going to end up being finalists and that sort of thing. We got kite making and kite flying competition going on. And when we return, following our next segment, I will let your appetite with something that's really interesting and new innovation that's bound to tickle your fancy. But right now, Michael, we're going to turn it over to some footage from the exhibitions, and we're going to feature the chemistry department under the trade name of Bioessence. And they're going to show us the process and the result of cold press soap making. So I'm going to toss it right back to John in the control room, and let's get the chemistry department and the footage of some of these exhibitions that we're displaying here today.
Welcome to Combermere School, the International Mathematics Day for 2025. We are here in Chemistry Lab 1, and I will just ask immediately for this young lady next to me to introduce herself.
Good morning, I am Jamila Jones. I'm the owner of Bioessence Laboratory. That is a business that I started in 2022, and I'm here today to demonstrate a few things that we make. We are doing soaps today, we're going to do some lip balms, and we're also going to do some lotions as well. So first we're demonstrating how we make soaps. We're just doing something simple so the students can get an idea of how it's done. They can ask questions, and obviously once you know the basics of how something works, you're free to fly. So that's what we're here to do. We're showing how math is used to make these things, how it's used in everyday life, how businesses use math to make products, to start from basic things like just a simple oil, water, a couple other things, put those together in a specific way to get a product. Then you can use the same thing to get something else.
Okay, so then it's obviously clear that you have a background in chemistry.
Yes.
So what did you study at school, and if you could share with me a little bit about what you studied and maybe where our students could go in the future.
Okay, well, I did all science at school, all from secondary school. I went to school at Spring Memorial, did science there, BCC, UE. Didn't get enough punishment in undergrad, went back again to do postgrad work in chemistry, where I got my PhD in 2018. I would have researched like how to use bagasse to make biofuels using bacteria. And then I continued on in science. I worked for a nonprofit organization where we look at, the nonprofit organization is Bioculture Education and Research Program. And we look at plant medicine and how it's traditionally used in Barbados. During that time as well, I also started my own business where I use all of those chemistry skills and all those biology skills to make products and also help people with their skincare.
Okay, excellent. So let's get right to it. Let's see how to make some soaps.
Yes. So we kind of went through it a little bit. So what I explained was that soaps are basically made from oils and butters, the fatty acids of the oils and the butters, plus a lye. In this case, we're making a bar soap, so we're using sodium hydroxide. And we're just doing something simple. We're using one oil today. So we already have that weighed out. We already have our lye solution made up. So we're just going to go straight into making our basic soap. We have everything measured, so we're just going to see if we can put some chemistry now and hope that things work how they're supposed to work.
Okay, so can't wait to see it.
All right, good. So we have our mold that we're going to use to put our soaps in. We've already got our oil measured out. So we're just going to now we're adding our lye water solution to the oil that's already been pre-made, and we hope for the best. So what some people do to speed up the process is they will use an immersion blender, but I did not set up my thing next to the plug, so we're just going to have to go back to Middle Ages where we will stir vigorously for a period of time. And then if I'm not stirring vigorously enough, I will ask one of the volunteers to hook me up with the immersion blender. So like I was saying before, I think you can use the immersion blender because sometimes you don't have patience with these things.
Yeah.
Yes, and plug it on the thing that you have to shift because the plugs are on the other side. All right, so let's just shift over. Let's just shift on. Good, so alright guys, so that's too noisy to speak over, but usually, so you'll just do this process for a little bit until it starts to emulsify. When you add something to lye, it warms up, and that's a part of the process. So this is cold process soap. Basically, what we're going to do is mix everything, and then we're going to put it in the molds, and then it will go through gel phase and do what it does, and then it will form the solid bar of soap. Another way of doing this is hot process soap. If you notice, by now I ain't got to ask our patience, but because in hot process soap you do the same thing, but then now you put it on heat, and then you mix and mix and mix and mix with from now until forever. I ain't got a lot of patience. They just put the things in the things and let them set themselves up without me having to do all of that work. mixing, right? Good. So once your soap or your batter starts to thicken, you can actually see it. But if you want to come a little bit closer so you can see how it looks. So what we call that is trace. Basically, it's a little bit late right now, but eventually you will see like it starting to make a little figure or settling on top of the mixture. By that time, you could pour it into the molds right now, or you could let it thicken a little bit. So you see it starting to thicken up. So you can choose to go a little bit further, but when you're doing this, you don't want to go too far because it might seize any container, and then you have problems getting it into the mold. Exactly. Yes. So you just make a little judgment call, and then you will pour it into the molds at the appropriate time. Even if you do it a little bit too early, it's still going to set itself up.
Okay.
So we started with the soaps first because this will take the longest to set up. This is probably not going to be ready until later this evening. Okay. You have to leave it for a few hours to saffronify and go through its little phase and create the soap bar. So that's basically it. I think this is basically ready to pour. Like I said, you could go a little bit longer, but I think we're good here. Okay. At this point now, we're just making a plain bar, but if you're going to add like a fragrance oil or an essential oil, this is the point now where you would add it. You want to do it after you've added the lye, so the lye doesn't scorch it too badly. And if you have something that is like, say I use coconut milk in some of my soap, this is the time you would add that as well. You don't want the lye to directly interact with certain things so it will scorch it and then discolor, or it might not have the same activity that you want it to have after.
I also notice sometimes people put like, I don't know, like bay leaf or something in there, so it is at this point I would do that too? Okay.
Yes, it's better to do certain things after you've added the lye so that the lye does not, it's still going to be warm in there because you still have lye in there doing something, but you don't want it to scorch what you're doing or destroy it. Even though, with the oils, exactly, not the other things. Yeah. In general, you still have to be careful what you put in your soap because this is a whole lye solution business going on here, and the lye is going to interfere with your additives, whatever you put in there. But the timing is where you want to work with, so you still have some preservation of your, what have you added. It could be aloe, essential oil, bay leaf, any type of extract that you put in there. So that I think we are ready to pour. It thickens as you go along. You can actually look on the surface and see it's making a little, so I think we are ready to pour into our mold, so we will shift. All right, you can unplug. Let me just get off the excess. You have a tissue that you can put this on so that back on the other side now. I apologize because I'm not here. So at this stage in the soap making process, you still want to be careful because it's still not set as yet, so you still have to be careful with how you handle your items. This is good side. Okay, so now you just simply pour into your mold. Try not to overfill like I did with that first one. Yeah, someone can try, someone with gloves can come and give it a try. Right, so just carefully pour into the... Just slow and steady. This is enough. That's fine. So continue another one? Yeah. Unless you want to give someone else a chance. Anyone else? Go ahead. Alright, so slow and steady.
Oh my gosh, you just pour.
Good. Another one, or if someone else wants to take a chance.
Mom, on the other hand, I don't want to pour.
Samira, Jamari, you want something? No? All right.
Like this, slow and steady. And that's all the volunteers we have pouring.
Soraya, you want to do it?
Alright, so let's just add it to this
Maybe
one.
this one could get a little bit more.
Add a little more this one?
Mhm.
Pop it down a little bit.
Come on, Soraya. Finish and top it down when you touch it.
Okay, and then you can pour the other one.
Ma'am, what? Ma'am, I was topping up one, ma'am. My bad.
Very good. Prefer to grab you with gloves because this still might still be because this could still be burny. Yeah, so rinse this off. Tissue. Yeah. Because it still has delay in there. It's not set yet, so you don't want to get burned. Right, so you can just pour into one of these little bowls there. Very slow and steady.
You got worry about air bubbles or anything?
Not really, no.
Right, okay.
Those tend to work themselves out, and we don't really get too much issues. So, anybody else or? Alright, so then we'll just use the rest of it to pour into another mold, another part. Any little bits and pieces we can fill up. No, it's true. So that is basically it. So like I said, this is cold process. Cold meaning that I haven't used any heat. I haven't put this now to heat on anything. It's just going to heat itself and it will set itself. It will go through what is called a gel phase. If you were heating it now, do the same exact process, but then now you will basically cook the soap and then add it to the mold. And let me see if we can spray it.
You know you were talking about it seizing up if you mix it too much.
Mm-hmm.
Does the heating speed up that process? Or does it?
If you
Or is the actual physical mixing?
the physical mixing will thicken it.
Okay.
If you when you're heating it, yeah, it's still going to do the same thing. It will just be like it's actually grow when you're heating it on the stove. You will actually see it bubbling or growing on you, basically. But I find this is a fairly straightforward, good process. I don't like using the cooking thing because I don't like things fluffing up at me. It's just like ain't no you mad at me at.
You
So
did say how long this is going to take.
right, so this is going to
hours.
take a few hours, yeah,
Okay.
because this needs to cool completely down now, and then that's when you will get your soap, basically. And then after that, now, basically when it has gone through saponification, it has cooled and everything is good, you have a soap. You don't have to wait for 6 weeks for the soap to set. Basically what's happening now, because the water that you use in your lay solution is basically a solvent for the hydroxide, so the two of them can mix. That really does nothing in the reaction. All you're doing when you're letting your soap dry is to let that water evaporate into the atmosphere. But you can use your soap the next day after you made it today. Some people will wait. It depends on how much water you use in your formulation. You will have to wait a certain amount of time. So because I use very little water, I only use enough water to dissolve the lye, I wait like around 2 weeks to let the soap dry and set. Whenever you first mold, your soap is a little bit tacky and a little bit soft. You have to leave it for that time to dry and set and become hard, and that's it. But you don't have to. You can use it the next day. But obviously, the longer you leave it to set, the harder it becomes, the longer it will last. You get a better soap bath, basically. It will last longer. But once the saponification process is done, that's it. You have a soap to use.
So you want to talk a little bit about proportions, because obviously we're going
Yes.
to mathematics.
Yes. So
how did we get this amount? What was your mixture? How much oil to how much light to how much water?
right, so
Proportions.
the reaction now between the oil and the hydroxide or the lye solution is really between the fatty acids and your lye. So there's a certain amount of lye necessary for each type of oil. So I use a simple recipe today with just one oil, the coconut oil, so that's very simple and straightforward. So what you would do now, if you're using coconut oil, sunflower oil, grapeseed oil, shea butter, cocoa butter, whatever, all of those now have a specific, what is called the alkali ratio. There's a specific value associated with how much lye you need for each one of those components with each, the coconut oil, the shea, whatever. So usually that's compiled in a table now. You can look it up online. It's the AR table or a saponification rate table. It will give you like a percentage or a decimal point. So you will take that now. I actually think I have it. No, I didn't bring that piece of paper, but basically now when you have your alkali ratio, the amount of lye necessary for like the coconut oil to make a soap or to mix with the alkaline, you will add up all of them. Like say you use this one, you use a simple thing, but you have coconut oil, grapeseed oil, sunflower oil, whatever. You take that value now, multiply it by how much you want. First you start your formulation. How much of proportions of what you're using. You use like 50% coconut oil, 20% shea, whatever have you. According to that now, you have your batch size. So we use like 350 grams today to make these 8 bars. If you're using something like that, these are 2 ounces each. You'll calculate for that how much total you want. If you use I use a slab mold, like a loaf or whatever. So we'll calculate how much the capacity of that is, how much you want to make. So let's say you have a batch size of 1,000. 50% of 1,000 is whatever, 500 grams. Well, you calculate that according to what you use in your formulation. Then you calculate now how much of the lye you need for each one of those oils. Multiply those two values, like the amount you need for the oil by the saponification value or your alkali ratio. That tells you how much sodium hydroxide you need. So like I said, in order for the sodium hydroxide now to mix with the oil to make a soap, it needs to be dissolved in the solvent. The solvent we're using is water. So I use very little water. There are lots of different calculations. You can probably go online and find people doing all sorts of different things. I just use something very simple. I use a 1-to-1 ratio. Whatever the amount of hydroxide, I use the same ratio of water. You just need enough to dissolve the hydroxide to get it into a solution or where it can mix with the oil or the butters or whatever you're using. And of course, all of that is math that you have to do first before you, before you mix anything. As Joy mentioned before, we are not going with the ancestors on this. We are mixing our things accordingly. No, because you don't want to end up with a soap now that is what is called lye heavy, where you have too much lye because you've miscalculated something. If you have lye in your soap, it will burn your skin. It's good not to have too much. You can have too much oil or you can have too much butter. It will just make the soap a little bit more gentler on your skin. Because it's just oil or butter. It will just go into your skin. But
certainly not the lye.
Certainly not the lye. It will burn your skin, and that's not what you want. So that.
Welcome back to the studios of Waterford University, where the time is 10:59. It's marching back on, and it's also 10:59 in the Eastern Caribbean. Michael, we have someone in the studio. Care to introduce us?
Yes. Good morning, everybody. Again, we have Kira Harewood, mathematics and economics teacher, and the person in charge of the scavenger hunt. So we're going to find out what exactly the scavenger hunt entails.
Yeah, can we get involved? What we can do? Tell me about it.
So tell me something about the scavenger hunt, Kira.
All right, so we've done the scavenger hunt before, and the children really enjoyed it. It's a really good idea because it's different from being inside the classroom all the time. They're doing it outdoors where they can just run free, have fun, and be interactive.
Mathematics themed, I would imagine.
Yes,
yeah, okay.
there are 10 questions,
right.
10 clues that they have to use, and they're all mathematically related.
Okay.
And they're given tablets. So you know children love technology. So the idea of giving them tablets is what made it even more fun. So they'll have the clue, and when they figure out the answer, they have to go and look for the answer on the compound.
They're operating in groups, are they?
So they're put into groups of 5. Yes.
Okay.
So they're put into groups of 5, and when they know the answer for the clue, they go onto they look for it, take the tablet and take a picture. And once they have all the pictures, they have 25 minutes to do the scavenger hunt in. So anybody who comes back after the 25-minute time frame will get penalized, like points taken off. So the group with the most points will win the scavenger hunt.
Let me ask you this. So they work the problem out, and from there you say you take a picture of what? They have to find the...
So for example, if the question says, find something with a 6 in the hundreds column, then I have to go around the school and look for something that has a 6 in the hundreds column.
So it's
I don't want
real
to give the
physical
answer in
activity.
case anybody might be watching. So they have to find it and take a picture.
Okay.
Yeah.
And then come back as group. And then, of course, they get collated, and then the prize winners are known.
Correct.
Okay,
yes.
all right.
So
How long will this normally take?
It's supposed to be 25 minutes. The last time we did it, I would say the majority of people came back maybe like 20 minutes.
You said they're too easy, eh?
I would say that some questions are easy and some are tricky.
Oh, okay.
Tricky, so I will not say too easy.
But all in all, they absolutely enjoy it.
They love it.
Yeah.
And I like it too because I like being outdoors too.
So this was your brainchild, this scavenger hunt?
No, when we did it, Miss Curtin was in charge of it.
Okay.
So she would have done the questions. I tweaked it a bit, and she was the one behind it the first time.
How far around the campus you let these children chase? How far?
Not all over because they can't be too wild. So we keep them contained in the area with the football field and maybe the basketball court. So
You're not giving anything away, right?
Pardon?
You're not giving anything away by saying that, right?
No.
Okay.
They're told that from the beginning.
Okay, good. This is wonderful. This is absolutely wonderful. Thanks very much, Kira. Thanks for this, and thanks for your involvement. This is turned to be a wonderful day. I want to toss it back to John in the studio, in the control room again, where he has queued up a video with Miss N. Pemberton.
I'm a math student. Of course I know our 8 lines. I'm a math student. Of course I know the Pythagoras theorem.
I'm a math student. Of course I love problems.
I'm a math student. Of course I use algebra in my everyday life.
I'm a math student. Of course I know 100 digits of pi. 3.141 plus 9, this is pi.
I'm a math student. Of course I love calculus.
I'm a math teacher. Of course, I'm always at work.
We're in junior school. Of course we love math.
Scientists in England say that pork fat good for you. And the best thing to fry in is the pork lard. I knew that ever since.
You can't eat with knife and fork.
That was spoil the taste. Smoked potatoes with a little fat from Carleton and Emerald City. Taste proper.
John is a father, a brother, a friend. His home is his pillar. It's where he finds strength. But life has a way of finding loose ends. And one day he lost hope when misfortune came. Then along came a promise of fortune to change. Fast, fair claim settlement and service that saves. So John and his family, with answers in tow, can look to the future with worry no more. CGI is here. Let's work it out.
Welcome back here in the studio. Michael, this has been going very, very smoothly. I have to give compliments again to all those who put it together and the staff behind the scenes, Mr. John Bryan. We talked about the scavenger hunt just now, Michael, but we got a worry competition. We got kite making and kite flying competition to come. Do you know about a jingle competition?
I've heard something.
Well, let me tell you something, Michael. There is a jingle competition, a mathematically themed jingle competition. And I got a little bit more information to share with you because this is so interesting. I happened, Michael, to actually download some of the lyrics of some of the jingles last night. And I laughed myself to sleep. Our children are so creative. And I cannot wait to get to hear some of these actual jingles.
I would like to hear them too.
Yeah, but right now, what we got an interview with Mr. Wiggins all queued up. Let me get that interview done, and then we come back and give you a little more information about the jingles. So take it back to you, John.
We're here with Mr. Wiggins, a member of the mathematics department for the last 3 years. And I'll start right away and get right into it. What inspired you, Mr. Wiggins, to become a mathematics teacher?
Well, great question. I would say that mathematics as a teacher was not in my plan. I would say that during the COVID season, it was a little rough, and I had to find a way to basically employ myself to really do something that I would say, how to push me and so forth. And I thought about teaching. And I tried it, and interesting enough, the door opened at Combermere for me to be here. So that, I would say, that's where I actually started from that moment.
Okay. I'm really glad to have you.
Okay, thanks.
So how do you motivate your students in the classroom, especially given the math anxiety that many students face?
Math anxiety, yeah, that is a major challenge that we have. I would say for me, my technique or my go-to is trying to get them to see it from a real life perspective. For me, going to school, I was kind of like, felt like if the teacher wasn't able to like make this practical for me, like how does this relate to my normal life? So for the students, I try to get them to like, kind of like look at math from their lives and see where does it fit. I even have a little challenge I give them from time to time where I would tell them, look, I give you $50 if you can find anything that, in life that does not include math. My children might try all kinds of things. But no matter what they bring, I'm able to tell it has a length, it got an angle, it has, something always about math is in this thing. Even like, I told them, even like, go into your fridge. Your fridge has a temperature you set it to, so you can set it to 10 degrees. And then you decide to go in the fridge. Most of the time we go to the fridge, we don't know what we want, we open, and then all of a sudden the temperature is rising in the fridge. You're not paying attention to that. But there's another variable that is there. So it's a variable of the setting you made, a variable of the temperature it really is. And when you close back the door, I'm sure many of you hear that hum. That hum is the fridge trying to cool itself back down. It's comparing the temperature of the fridge after you close the door and the temperature you set it at. So if it was at 10 degrees, it went to 15, it's going backwards 14, 13, and when it gets back to 10, I'm sure you'll hear that hum stop. And that's when it has bottom out there. And that is algebra in your fridge. So when they see that, I think some of them realize that, you know what, math is actually in everything.
Okay, awesome. So you talked about practicality. Let's deal with the students that we have today and today's educational landscape. What would you say is your strategy for encouraging that positive environment in your class?
Well, that is an interesting one. Interestingly enough, when I went to Earth recently, I would say this much that was actually one of my actual research project. And I would say that one of the techniques that came out of that was one called gamification. I find that students today, because of their short attention span, I find that they will not really, especially maths, stick to you on a board, just writing, sums, writing. So there are lots of websites that are out now, and I try to merge that technology in the classroom. So like, for example, there's Math Playground, where you can take the tablets and give to students. And you may have, like, for example, a tug of war. So I would give the girls probably 2 tablets, the boys 2 tablets. And what they would do say is that these sums will come up on the screen, of which I have projected for the entire class to see. So it may have, like, for example, 2 multiplied by 10. Now the team that obviously is able to answer more questions than that tug of war on the screen, will pull their team to the winning side.
Okay.
So if the boys are faster in getting in the answers, their team goes to the right. And if the girls are faster, they go to the left. And there, let me tell you, the only thing that I sometimes have to be cognizant of is the environment I'm in, because it's still going to be cognizant of the other classes around, because it's very, very engaging, and the children love competition. So that's one of the things I use to try to keep them engaged throughout the class.
Okay. Yeah, that sounds awesome. I wish it was in your class.
I don't want to invite you a free invitation to come every night, Yes.
All right, just shifting gears slightly to this year's International Day of Mathematics.
Yes.
There's an activity for the first form students, kite flying. Can you tell us more about that? What's the link between kite flying and math?
Okay, kite flying. When this activity came up, we thought about how could we make math fun while still teaching them, again, about maths.
Right.
We thought about kite flying. We do not want the children to buy a kite. We are. I mean, beyond the fact that we also realize that many children never even get a kite. And it seems to be a lost art that we have. I remember back in the day, I used to make kites out of trash bone, from the cane fields. Telling that to a child now is like, But we get them to actually try to make the kite from scratch. So they have to be cognizant that you have to have the bones, what we call the actual frame of the kite. So they have to actually measure the stakes. You can have one stake that is, X amount of centimeters or inches, and another one a whole different size. Or the kite isn't going to come together unless you are doing a different shape, depending on what your target or your aim is. But to get them to actually build it involves maths. The measuring of things, having to angle things to be able to fit the shape you want. The amount of string you need to go around the edge, It's a lot of maths involved. We're talking about art and creativity this year, so the design that they're going to do for the actual face of the kite, back in the day we used newspaper, that was very artistic, but they're going to use a lot of color and shapes and things to try to bring it to life, and then they're going to try to make the tail of the kite, certain of it. Some of the lessons we wanted to learn are like when you set the loops certain lengths, that the kite would actually fly higher.
Right.
And you set it a different way and it flies further.
Yes.
And we wanted to be able to see that correlation between the angles that they create in the loops. And then also, while they stand on the ground, the string that they're holding is creating an angle from the ground up into the air. We wanted to see that from the ground up to that string creates an angle. But first form, we don't really teach angle of elevation, but if you're in third form, you have a few third formers out there in the pasture watching, they'll be able to see that in practicality, how we actually teach that subject and what that actually means. So the kite fly activity is for fun, but at the same time we want them to see the mathematics in it.
Okay, well, we're definitely looking forward to seeing how our first formers engage with this kite
Yeah.
flying activity. And it was great having you chatting with us today. Thank you.
Thank you so very much. Yeah.
Thank you. Welcome back. Just continuing a little bit more of the history and some trivia as it relates to International Day of Mathematics. In 2018, a sixth form student approached the head of the Department of our Mathematics department here at Combermere, expressing an interest in taking part in a mathematics contest put on by the University of Waterloo in Canada. Her insistence was such that she sent the head of the department links to the website so that the relevant research could be done and how to afford her this opportunity. Such was the enthusiasm about mathematics here at Combermere. Through collaboration with the head of the department at Queen's College at the time, the student was afforded the opportunity and she entered along with students from Queen's College. So the enthusiasm surrounding the learning of mathematics has always been very, very, very poignant here at Combermere School. So we're going to go into another interview. Michael, who do we have queued up now?
Which interview?
Euler.
We're going to have an interview.
Well, footage.
Footage, sorry.
Yeah.
Of the Oilers. So at this stage, I can send it right back to John. and
Yes.
we have footage of the Eulers.
Euler's discovery in the second form. So back to you, John.
All right, we are here in Form 2B with Ms. Laborde Herbert, and we are looking at one of the activities for the International Day of Mathematics 2025 right here at Combermere School. So, Ms. Laborde Herbert, could you give us a little overview as to what this activity is about?
Well, this activity is for the second formers. They are doing Euler's discovery. And the aim of this activity is to determine the relationship between the number of vertices, faces, and edges in a convex regular polyhedron.
How would this particular activity help them in understanding maybe shapes, geometry? How does it help?
Well, this activity is an independent discovery activity. They have the paper before them, which they are to follow the instructions on it, and it will help them to develop their independent thinking in terms of the shape that's before them, and also, from what I did before in 2D, gain some confidence in terms of once they're finished with it, they feel like they've accomplished something, positive and something great in terms of mathematics.
So maybe we could take a look at some of the nets that the students would have gotten, and you could kind of give me an overview. So as you can see, what they would have done, I guess each group of students would have gotten one of these, or two of these. Explain that to me.
So each group has each person has a different net. So there are 5 nets, and each person in the group has a different net related to a different solid.
Okay.
And the solids that we have are the tetrahedron, the dodecahedron, icosahedron, the octahedron, and the cube.
Okay, all right. So we can go around and let's take a look at some of the groups actively working.
Yes.
So that we can get a better understanding of what's happening. All right, so as I can see from this group, they are working on, some persons are doing a crossword while other persons are actively, and as Ms. Laborde Herbert said, they are actively cutting out their net to see what shape they're going to end up with. So we can't wait to see Ms. Laborde Herbert, the end result of what was going to happen with 2B. So the creativity, the art, the mathematics is definitely being showcased with this particular Euler's discovery activity. And I want to say thank you very much. So can't wait to see the end result. Thank you.
All right, thanks.
And welcome back. Welcome back. With the time has rolled on to 11:20. We've been here for almost an hour and a half, Michael. I don't know where the time has gone. But we got two wonderful people in the studio now. Let's introduce them, Mike.
We have Victoria Grace, the faculty advisor for the Literary and Debating Society. And what's his name?
DeMarco.
DeMarco. He's a member, an active member of the society.
Yes.
Right. So, Ms. Graves, tell us a little bit more about the Literary and Debating Society. That was one of my favorite society extracurricular activities here when I was here.
Right.
Tell us where we have advanced that.
Okay, well, you'll be happy to know that the society is still functioning.
Wonderful.
Yes, so we've been here for many, many years. Currently, we meet on Tuesday afternoons in the hall. We normally meet in a classroom, but it became such an experience. So many people wanted to join that we had to move from the classroom to the hall just to accommodate everyone.
That's wonderful.
So
You got a lot of talkers that come in.
We got a lot of talkers. Everybody wants to have a chance to have their say, and there's students who I would have seen from first form up to senior school now who, when they first started coming, were very shy, not very confident, couldn't speak in front of a crowd, but now they're competing in competitions, they're participating in debates, they're volunteering for everything. So just being able to see that progression of consistently coming and participating and meeting with like-minded students, I think really helps those who, even though you may think, oh, you're shy, you don't want to come out your shell, they can. It's just that they need an environment in which to do so.
Right.
So I think that this is the right club for them.
Wonderful, Michael. It seems to me that we got a transformational figure right here in front of us.
I need to find out about DeMarco's actual involvement. Were you one of these students who were shy at first, but now ready to talk in front of the whole world?
Yes, I was. I believe that the Literary and Debating Society boosted my confidence. And as a law student, we usually discuss pressing topics, politics, the government, world issues by playing games. And to see all these students come on a Tuesday evening is really amazing because they're actually interested in learning new stuff and new skills. And
So,
meeting new
DeMarco,
people.
I got a
Yes,
question
please.
for you. Which side you prefer to be on? You like to propose or you like to oppose?
I normally like to oppose, but being in proposition is good as well.
Yeah, because you know that the proposition is the only one that can actually prepare for his debate.
Yes.
So if you like to oppose, that means you have a very special skill. That means that you actually have
I
to
do.
do it on the fly and create your arguments. So how you feel you're getting on with that?
It may be challenging sometimes,
Yeah.
but this is something I'm interested in, and if I'm interested in it, I'll try my best to do my best.
Yeah. So I need to, Michael, sorry, but you know.
But I mean, she said that we used to meet in the classroom.
Yeah.
So
And
then
then now in the
morphed into
hall.
the hall. So that tells me that there are quite a few students who are interested.
Yeah.
So as you said, there's a lot of talkers, but I don't think it's just a lot of talkers. I think these children want to be involved in something that's stimulating, and that they find, they want to be a part of it.
Exactly.
So it's really great.
That is
It's
great.
really
Where
great.
do you find they get the inspiration from? Politics or just current events?
A lot of the time it's current events.
Yeah.
Current events. So even sometimes when we get to club, their friends have invited them. So they had a friend that was coming, and then this friend brings two more, and then they start to want to talk about the things that they're talking in their friend groups, whatever's the latest trend, or simple things sometimes, but sometimes it's bigger issues. So we like to do a lot of games as well, because that's how you learn, and it makes it fun for everybody.
How much does social media play in this in terms of what stimulates you? Now, let me ask you this. Are you a news junkie? You find yourself watching news programs? What kind of programs do you find yourself gravitating to that would stimulate you?
Well, I don't really watch a lot of news, only if it's something for school. But now, recently, I have really gotten into news as I'm a law student, and it's really interesting to know what's going on in my world.
Michael, that's a very good point. I mean, morphing from a classroom to the hall
Yes.
is a big step.
Yeah.
You know, typically you take more from there to the library, but you more from a classroom to the
the
hall.
hall.
How many students do you think will be involved in this in excess of 40?
Yeah.
Oh my goodness.
Sometimes we have close to 50 students.
50 students.
Across the entire
Across
age group?
the age group. First,
first, second, third, fourth, fifth, sixth.
This is amazing. This is amazing. And participation, males to females, equal or?
We have a lot of junior girls right now, not a lot of junior boys, but we have a lot of senior boys.
Okay.
So I think that is helpful as well. Yeah.
Oh, nice. So, are we into school competitions as yet? Or this is planned?
Actually, that's the plan because we actually, as a group, we went to the Christchurch Foundation School. They had their inter-host debate competition about 2 weeks ago.
Do we have one here as well?
We don't have one here, but I am.
We used to have it years ago.
You used to have it
years and years ago, yeah. But it needs to be something that needs to be pushed.
I'm trying to get it back on track because that's something I used to have at my old school. So it's something I would like to see here as well. The only thing
I hope you're all members of Set D. I don't mind what my color is.
I am Set A.
Oh dear. Oh my goodness. All right, don't worry, my guys. I'm outnumbered.
Yeah.
This is really good. I love to see what you're doing. I keep abreast of it because I love to hear how the students are actually advancing.
Yeah, so we're trying to forge some relationships between the two schools. So we will probably have Christchurch Foundation come and spend an afternoon with us before the end of the term, hopefully.
Yeah.
And I think there's a club at the Lodge School as well. So just trying to do some more connections.
Very good. One more question for me to the Marco is how long have you been at it?
I actually started debating club in late last year.
Oh.
I wasn't very active, but now that I'm in sixth form, I'm very active because it's really interesting. It really is.
Do you find yourself having to mentor young people, or that's
Yes, I do. A lot of the keys. They always ask me questions about, is law easy? Is law easy? And I say, no, it's not easy. But if you join debate club, I'm sure it will be very
You've got a salesperson here for this business.
For my law program?
Yeah, your law program.
Very good. Yes.
So I see all smiles. You seem very happy with the success of this.
Yeah.
And I want to give you my full support because I think this is wonderful.
Thank you very much. So for Math Day, Ms. Combermere asked us if we would be able to do something similar after seeing us participate in the Old Scholars. They had a debate for Old Scholars.
Yes.
Week. So we said yes, of course, and the children were quite excited. So we allowed them to choose the topic that they wanted. So we actually gave AI some prompts.
Nice.
And it threw back some topics at us.
Yes.
And then we used the topics that we got from the AI.
So technology is really playing a part.
Yeah, to do like a poll and see what topic interested them most based on the math, art, and creativity theme.
Was wonderful.
They went with math is more valuable than art at fostering creativity.
And which side are you on?
I was on the proposition side.
That is a very interesting topic, I have to say. I'm not going to ask you your technique, so I was actually thinking it over last night and was wondering how I would tackle it myself. This has been wonderful chatting to you.
Yes, please.
Wonderful chatting to you. Thanks very much for taking the time out to come and talk to us.
Not a problem.
John, I'm going to toss it back to you in the control room for our next queued up item. All right, thank you. And we got a special treat for you. We are going to go into the debate and we're going to watch the Marco in action. Tell us what the debate was all about.
Yes, so the topic for the debate is math is more valuable than art in fostering creativity.
Interesting topic. Let's see how they do. Over to you, John.
Welcome to today's debate. My name is Shasni Thorpe, and I am the speaker of the House. I will regulate the speeches given in this House. Our parliamentary style debate this afternoon is on the topic, mathematics is more valuable than art in fostering creativity. The timing for our speeches is as follows: 3 to 5 minutes for everyone except the whips. At 3 minutes, the green card will be shown. At 4 minutes and 30 seconds, the red card will be shown. For the whips, you will have 2 to 3 minutes to speak. And at 1 minute 30 seconds, the green card would be shown. At 2 minutes and 30 seconds, the red card would be shown. The order of the debate is as follows: Prime Minister,
Kadean Archer,
Leader of the Opposition,
Rebecca Waterman,
Deputy Prime Minister,
DeMarco Went,
Deputy Opposition Leader,
Naomi Brown,
Government Prime Minister,
Omri Patrick,
Member of the Opposition,
Roche Carrington,
Opposition Whip,
Sahara Proverbs,
Proposition Whip.
Ciara Corsers.
We will begin with the proposition. I now invite the speaker to speak. The Prime Minister to speak.
Good day to one and all. The motion for debate today is math is better than art at fostering creativity. Now, we as today's proposition strongly believe that this is true. But before we come to our actual argumentation, let us first define some important terms in this debate. In this debate, we use psychologist Keith Sawyer's definition of creativity, the result of innovative thought coupled with action, defining mathematics as the abstract science of number, quantity, and space, either as abstract concepts or as applied to other disciplines such as physics and engineering, and art as the expression or application of human creative skill and imagination, typically in visual form. Right now, the situation is that less students are developing interest in mathematics, leading to a decline in mathematicians, engineers, financial analysts, architects, and other related occupations in the Caribbean. This creates a major issue because mathematics is a cornerstone of several crucial aspects of our lives, from as menial as counting pocket change to ensuring the stability of our infrastructure, reducing economic costs for architectural and logistical matters, and ensuring the safety of the population. In a meeting with CARICOM heads of government, Dr. Irfan Ali noted inter alia that it has become a collective issue that we must address, it referring to the disturbing lack of student interest for math in the region, as well as lower pass rates in the Caribbean at CSET level. Emphasizing the importance of our model. Our model suggests that the key to increasing student interest in mathematics would be to prove that once and for all, mathematics is the superior subject in terms of fostering creativity. I, as the first speaker, will be talking about how crucial math is in terms of fostering creativity, giving relatable examples. Our second speaker, DeMarco, will elaborate on the fact that math is the true heart of creativity, touching on theories and supporting philosophies. Our third speaker, Omri, will speak about its application and its role in creating many famous inventions. And our final speaker, the whip, Ciara, will do the rebuttal. Mathematics is far superior than art in fostering creativity in that it provides a broader application of creative and innovative thinking, with many forms of conceptualization and application, such as designing physics engines for realistic video games and improving animation quality in cinema. In an article published February this year by Online Math Center, among other things, it was stated that many of the movies and video games that we enjoy have tons of mathematical ingenuity and creativity that goes on behind the scenes. Examples include the character of Sullivan from Monsters, Inc. and Merida from Brave. Both Merida's fiery curls and Sully's detailed fur have been designed through mathematical processes. In addition, Doctor Strange's visually stunning and breathtaking mirror dimension was also a product of mathematical artistry and design. When it comes to special effects in movies, generation through careful mathematical design ensures that it is realistic in how much light enters a space, how fast explosions expand, the degree to which debris flies after sudden impact, and so on. In terms of superheroes, The Flash is a great example, particularly the scenes where he runs and how realistically the environment is affected. Like how he runs on water, up buildings, all these cool visual effects we know and love would be nothing without mathematics, and that's a fact. While art does play some role, it does not account for many of the intricate and realistic visuals that give us chills when we are in the cinema. And for video games, the same argument would apply, since many other components such as randomness and probability, an example being item boxes in Mario Kart or chance systems in gacha-based games like Pokemon, will be hiding in the tall grass and so on. In fact, algebra allows developers to describe the relationships between various elements in the game, geometry adds in the rendering process, and in unique in-game environments. One last mention is Combermere's Ultimate Warrior competition scheduled to take place this Friday. It is a perfect example of how an entertaining game can motivate you to think critically through mathematics, but learning the mechanics of the game. That's all for my section of the argument. Thank you for your attention.
Leader of the opposition.
Good evening, all. What is mathematics? Math is the use of numbers, fractions, and symbols to solve and create problems or formulas. I am a true believer that mathematics is laid the foundation for the world we live in today, and I do believe that it's integral to our society. But by a show of hands, how many people can truly say that that all these mechanisms that we have today were not invented without the creativity of many artists? By a show of hands? Mathematics is by no doubt a subject which provides the use of creative thinking and intuition through the use of problem solving and pattern recognition, while visualizing solutions such as spotting symmetry in geography or finding shortcuts in algebra, and even through the use of mathematical modeling or real-world applications. For example, scientists and engineers collectively apply math to solve real-world problems, like predicting weather, optimizing traffic flow, or designing AI algorithms. However, mathematics is very structured and formulaic, which art, on the other hand, is not. Art can be used to express one's self, emotions, thoughts, and struggles. Art is about intuitive thinking and self-expression. For example, a painter doesn't need to have or understand art theory to create a masterpiece. For example, Van Gogh struggled with anatomy and was even sent to art lessons for children. Yet he managed to produce many works of art. While artists like Paul Cézanne, famous for the painting The Card Players, and Frida Kahlo, known for her self-portrait like Two Fridas or Self-Portrait with Monkey, also lacked formal training, but made substantial contributions to art. Art allows its users to be free and express their true selves, while math follows rules and regulations. Without art, many of us would not have many of the things we have now. For example, who do you think creates the drawings to make the construction of buildings? For example, even Combermere School, I'm sure there were many drawings made to create the foundation and later the construction of this grand building. Art allows its users to be free and express their true self, while math regulates and keeps the users in a box. Suffice it to say that while math does allow creativity, art allows a person to truly be themselves. This is my ending.
Point of introduction.
Did you get permission to speak?
Forgive me.
As denied. Denied. We will now carry on with Deputy Prime Minister.
Ladies and gentlemen, Madam Speaker, when we think about creativity, we often picture an artist paintbrush in hand, making magic on a canvas. But I ask you, do we really believe that creativity is limited to colors and brushstrokes? If so, like the old Bajan say, your head emptier than the church on Kadumant Day. So let me educate you. Mathematics is the true engine of creativity. Why? Because math isn't just about numbers and equations, it's about thinking beyond the limits of what we know. Let's talk about one of the greatest minds in history, Albert Einstein. His theories were not just dry calculations. They were bold, imaginative leaps that transform how we see reality. His theory of relativity, for example, wasn't just about numbers. It was a groundbreaking idea that challenged centuries of scientific thought. He visualized light beams traveling through space, imagined what it would be like to move at the speed of light. And from these mental experiments, he reshaped mathematics and physics. This is the kind of creativity that goes beyond aesthetics. It changes the fundamental understanding of our universe. Can a painting do that? Maybe, but not nearly as efficient. Additionally, in a 2012 study by the Department of Math at Harvard University, stated that 90% of mathematicians, including Einstein, believe that problem solving in mathematics and physics requires as much creativity as traditional arts. And let's not forget, math isn't just theoretical, it's practical. It's the secret force behind everyday creativity. Think about it. Cooking is a perfect example. Whether it's doubling a recipe, adjusting ingredients, or even perfecting the chemistry behind baking, all of it requires mathematical reasoning. Similarly, athletes rely on math, even if they don't realize it. A basketball player calculates angles and trajectories when making a shot. A footballer adjusts their power and timing when passing. These are all real-time mathematical applications that enhance performance. Now, some might argue that art is a heart of creativity, but let's take a closer look. Even some of the greatest artists use math. Leonardo da Vinci, for example, Leonardo da Vinci's Virtual Man is a prime example of the craft of mathematics. His precise understanding of proportions and symmetry came from his studies in geometry and anatomy. The same applies into the Renaissance paintings that use the golden ratio, a mathematical principle that creates aesthetically pleasing compositions. In fact, we remove math from art, and what do we have? Stick figures. And speaking of the arts, guess what? Even music is math-based. Music is often seen as purely artistic, but at its core, it's mathematical. Rhythms follow specific time signatures, harmonics are based on frequency ratios, even musical scales are built on precise mathematical patterns. This is why music and math go hand in hand. Composers, producers, and even DJs use mathematical principles to structure sound in a way that resonates with us emotionally. Without math, your favorite songs wouldn't even exist. But let's go even deeper. Digital art, animation, and architecture wouldn't even exist without the precise calculations and algorithms that math provides. As my Prime Minister would have touched on, in animation, everything from character movement to simulations relies on mathematical principles such as geometry, trigonometry, and calculus. The smooth transitions in CGI movies are powered by matrix transformations and linear algebra, allowing for realistic textures, shading, and lighting effects. Architecture, too, is deeply rooted in mathematics. Engineers and designers use geometric modeling, symmetry, and structural calculations to create buildings that are both aesthetically pleasing and structurally sound. And when it comes to video games, every frame, every character motion, and every realistic interaction is governed by mathematical models. Whether creating a virtual world or designing a physical space, mathematics is the invisible force shaping what we see and experience. And unlike art, which is often limited by materials, physical ability, and styles, math is limitless. Also, something quite popular in today's schools, the rise of artificial intelligence is a testament to the limitless power of mathematics. AI systems are built on complex mathematical models, including algorithms, probability, and linear algebra, which enable machines to recognize patterns, make decisions, and even improve over time through machine learning. From self-driven cars to advanced robots, AI is transforming industries by solving problems beyond human capability. And let's not ignore the big picture. Mathematical creativity is what drives our most groundbreaking discoveries. Medicine, the COVID-19 vaccine was developed using complex mathematical modeling. Mathematics plays a crucial role in medicine, from modern disease spread and medical imaging to drug formulation and personalized treatment plans. It enables precise calculations in diagnostics, surgical procedures, and biomedical research, improving patient care and medical advancements. Engineering, space exploration, all powered by innovation, mathematical thinking, as said in a 2018 interview by Elon Musk himself. That's what math does. So next time you think about creativity, remember this. While art captures what we see, math shapes what we dream, builds what we imagine, and powers the innovations that move humanity forward. Thank you very much.
Mr. Chairperson, on a point of order.
May you please repeat?
On a point of order, may I ask the proposition a question?
You may.
The Deputy Minister just made an interesting statement that art without math would just be stick figures, but I'm curious as to what you have to say about things like abstract art or artists that like to do presentations in a very untraditional way using abstract drawings or uneven lines. What would you say to that?
Does an abstract art include shapes? What are shapes? Don't you see shapes in math?
Abstract art purposefully goes against traditional shapes. In fact, they often use obscure or unrecognizable patterns that don't traditionally appeal to mathematical concepts. For instance, was it abstract? Was it surrealism? Yes, I think that's what it was called.
Deputy Opposition Leader.
Good afternoon. I stand in full support of the motion that art is more valuable than mathematics in fostering creativity. While math is important in many areas, when it comes to creativity, the ability to think outside the box, express new ideas, and inspire change, art has the bigger impact. First of all, art has no limits. It allows people to express their ideas in ways that are completely original. Mathematics, on the other hand, follows strict rules. There is usually only one correct answer, and every problem must be solved in a certain way. But with art, there are infinite possibilities. Take abstract art, for example. It doesn't follow logic or set rules. Instead, it encourages people to explore ideas that might not even make sense in the real world. The Renaissance period is a perfect example of how art pushed the boundaries of creativity, and Renaissance artists like Leonardo da Vinci even influenced science and technology, proving that art inspires innovation. But art isn't just about coming up with new ideas. It's about emotion and storytelling. Art allows people to express how they feel and share unique perspectives of the world. A song, a poem, or a painting can tell a story that connects with people on a deep level. It can make us feel happy, sad, inspired, or even change the way we see the world. Can a math equation do that? No. Throughout history, art has been at the center of powerful movements, from protest songs in the civil rights era to photography that has exposed injustice. Art speaks in a way that numbers cannot. Madam Speaker, another reason that art is more valuable in fostering creativity is that it is at the foundation of so many industries. Design, fashion, film, music, advertising, and even video games all rely on artistic creativity first. Before a movie is made, someone has to come up with the story and the characters. Before a video game is developed, artists design the worlds and characters, even architecture, with a creative vision before math is used to build. Without art, these industries won't even exist. Unlike math, which can be intimidating and difficult to understand, art is for everyone. You don't need a degree or advanced training to create something meaningful. Anyone can pick up a paintbrush, write a poem, or play an instrument. Art allows people from all backgrounds to express themselves freely. Think about street art or music culture. Many of the most creative and influential artists never had formal training, but their work still changed the world. Creativity in art isn't about getting the right answer. It's about making something that matters. In the end, art fosters creativity in ways that math simply cannot. Art encourages imagination, storytelling, self-expression, and innovation. It is the heart of industries that shape our world and a tool for sharing emotions and ideas. Without art, life will be dull and uninspired. Madam Speaker, I leave you with this. Math may help us solve problems, but art helps us create possibilities. Thank you.
Madam Speaker.
Pardon me?
May I go ahead with the points of information?
Yes, to me.
May I introduce a point of information?
Yes, to me. Granted.
Pardon me?
Granted.
Granted? Okay. You made mention to the importance of art in things like, I believe, architecture, building plans, designing behind the studio, and that's great and all, but art makes something beautiful, yes, I understand, but there are concepts behind that beauty that art produces that stem from mathematics. The concept of abstract art, yes, it goes against the traditional shapes, but at the end of the day, they are still shapes. And where do shapes rely on? Geometry. And what does geometry stem from? Mathematics. So although you try to bring the attention further and further from mathematics, at the end of the day, the core of a lot of things that you're mentioning do stem from mathematics. Architecture, you draw the building plans, yes, but you still need to measure, you still need to take a lot of mathematical things into consideration. Thank you.
Madam Speaker, may I respond?
Yes, to me.
I'm not disagreeing with you that math is used in architecture, but imagine this. You're building a building. It looks, mathematically, it's correct. But what about the artistic side to it? Look at this school, for example. It's built wonderfully. The building doesn't look like it's about to fall down anytime soon. But it's also very beautiful. The person that must design this school must have had an artistic genius in his or her mind. Thank you.
May I respond, Madam Speaker?
No, please. Next up is Government Minister.
Ladies and gentlemen, Madam Speaker, good afternoon. Oxford Languages and Dictionary states that art is the expression or application of human creative skill and imagination, typically in a visual form such as painting or sculpture. producing works to be appreciated primarily for their beauty or emotional power. For example, the various branches of creative activities such as painting, music, literature, and dance. To foster is to encourage or promote the development of something. The opposition may aim to state that art is the so-called end result and math is just a pathway to creativity, and therefore is not creative itself. However, they seem to be a bit confused with the overall motion of this debate. We are not just here to talk about whether math is creative, but instead to talk about whether math is better at fostering creativity than art. We can easily see from this definition that art does not foster or promote creativity, for they themselves state that art is the application of human imagination. Therefore, it does not foster creativity, but is simply an expression of what is already in the mind. Math, on the other hand, is seen to have continually established logical and systematic ways of thinking. It also assists in developing mental patterns. Patterns used in music to produce harmonious melodies, create form, study the tempo, and help with chord progression. For example, Mozart, using the Fibonacci sequence in his Piano Sonata No. 1 in C major. Even Beethoven, who was notably terrible at mathematics, by the way, unexpectedly used group theory type concepts to compose his famous Fifth Symphony, patterns that Leonardo da Vinci used in the same art they so eagerly defend. Sacral geography, and more precisely, the golden ratio, were heavily embodied in his work. Even modern day art in some aspect, whether the artists know or not, still reflects the world of mathematics. Something as simple as applying paint to a canvas is a part of the additive process, which, by the way, is math. Significant roles such as architects also have incorporated geometry, algebra, and trigonometry into the design of buildings for more than 2,000 years. You cannot escape math. You cannot ignore it. You can try to deny it, but you cannot escape it. I can choose to not look at an ugly painting, however, and that will in no way have a significant impact on my life. The opposition may also choose to state that math is rigid because there is only one answer. Well, art allows you to be free, but art also has its answers. And just because something may not have an answer, does that make it free? Or does that make it jumbled, unorganized, and topsy-turvy? But really and truly, if art was free, why is it a taught school subject and university course? Doesn't that mean that there is a method, a correct and wrong answer? A theory to it all? After all, you cannot make a black cake without the fruits, nuts, rum, and therefore you cannot make art without maths. Art is merely the result of the open-mindedness, imagination, innovation, and emotions expressed through the minds of human beings who have been significantly impacted by the scope of mathematics. Art, therefore, does not foster creativity. We foster creativity through the enduring world of mathematics. There is a reason why research analysts, financial managers, software developers, and statisticians are some of the most highly paid and sought after positions in this century. So as I conclude, Ms. Speaker, the opposition could never be more wrong to insist that art is a true reason for smartphones, space shuttles, buildings, cars, and the vast amount of creativity and ingenuity that is seen throughout the world that math is evidently the backbone of. And they should be exceedingly shameful for wasting the public's time with this irrelevant, invalid, and unreliable showcase of their ludicrous opposition to the motion.
Member of the opposition.
Hello, everyone. Good morning. Now, I'm sure you're all very familiar. Yes, mathematics, a tool of the sciences, a major cog in innovation. It shaped our world, guiding the greatest minds, Albert Einstein, his theory of relativity, Sir Isaac Newton, his laws of motion. Math put a man on the moon. Math powers modern technology. It's as fundamental to daily life as something as simple as measuring money. And yeah, while math's significance in development and progress is undeniable, to claim that mathematics fosters creativity more than art, now that is something we need to discuss. But if I'm allowed, may I ask a simple question? Has anyone in this room been inspired by a math formula? Too vague? Okay, I understand. Let me rephrase. Has anyone, and I mean anyone, ever felt a spark of creativity while doing the quadratic formula or algebra? Fascinating, isn't it? But let's not stop there. Let me ask you, what comes to mind when you hear the word creativity? According to California State University, creativity is the tendency to generate or recognize ideas, alternatives, or possibilities that may be useful in solving problems, communicating with others, and entertaining ourselves. Creativity thrives on freedom, exploration, and expression. And yes, mathematics is bound by straight rules. Think about it. When was the last time you saw a mathematician break the rules just for the sake of self-expression? Okay, put it into perspective. Imagine this. Submit 2 + 2 = 5 and call it abstract math. I don't think that would be called creativity. I think that would be called failing the test. But even in creative fields like physics and engineering, mathematics operates within pre-existing frameworks. Any creativity involved is about finding solutions within constraints rather than open-ended exploration. It is a problem-solving tool, not the spark of imagination that defines creativity. Now, don't get me wrong, math does play a role in the arts. I'm sure we've all heard of him. We're all very familiar with him by now. By the end of this debate, I'm sure. Leonardo da Vinci, a prime example. A brilliant scientist, an artist who incorporated mathematical principles like symmetry, perspective, and proportions to enhance artistic expression. But that's the key. Math enhances creativity. It does not create it. Let's put it this way. A cake is more than its ingredients. Art is more than its mathematical concepts that refine it. After all, no one eats a cake and raves about them flour measurements. Creativity itself comes from the artist's imagination, emotions, and vision, not equations and formulas. Now here's an interesting thought. Did you know that many mathematical breakthroughs were inspired by artistic concepts and not the other way around? Take the Fibonacci sequence. While its mathematical properties are fascinating, its aesthetic applications in nature and art make it widely appreciated. The golden spiral, found in architecture, paintings, and photography, is admired for its beauty, not its numbers. Renaissance artists, such as Vincent, use artistic intuition long before mathematical principles behind proportions were formally recognized. In fact, his famous Vitruvian Man influenced mathematical studies, not the other way around. And it's not just visual art. Did you know Einstein credited his creativity to his love of music, his creativity in physics to his love of music? He once said that he often imagined his theories as musical compositions before expressing them mathematically. So if he never picked up a violin, who knows? Maybe we would still be arguing if time is relative or not. This shows how artistic thought processes fuel groundbreaking ideas, while mathematics merely provides a language to formalize them. Now let's flip the argument. If math were the primary driver of creativity, mathematicians would be leading the artistic innovation, wouldn't they? But are they? Think about it. The most creative individuals in history, Picasso, Shakespeare, Hendrix, did any of them rely on mathematical inspiration? Now let's flip the argument. If math were the primary driver of creativity, the golden ratio in many artworks, but artists do not rely on it to inspire their ideas. Some of the most expressive and influential artistic movements, abstract expressionism, Dadaism, surrealism, merely reject mathematical precision. Consider Jackson Pollock's chaotic yet profound paintings. They have no mathematical foundation, yet they revolutionized modern art. If math dictated art, Pollock would have been arrested for crimes against geometry. Or Frida Kahlo's deeply personal paintings, raw with emotion, guided by intuition, not numbers. Van Gogh's Starry Night evokes intense feelings through swirling brushstrokes and vivid colors, not through calculations. Even Jimi Hendrix, who couldn't read a sheet of music, changed the very course of music history. So let's be clear. Mathematics is an essential tool for refining and improving artistic work, but it is also incredibly useful in architecture, design, even music theory. But do not confuse utility with inspiration. Mathematics enhances creativity. It does not create it. So I ask you, where does true creativity come from? That is the real question. Thank you.
Opposition with?
Madam Speaker, my team has clearly shown that art, not math, is the true driver of creativity. Creativity is born from imagination, emotions, and human experiences, not rigid formulas or calculations. While mathematics may help structure artistic works, it does not inspire them. The greatest artists, from Van Gogh to Hendrix, created groundbreaking works without relying on mathematical principles, proving that creativity thrives without numbers. Art is about breaking rules, exploring new perspectives, and expressing ideas in ways math could never. If math were more valuable for creativity, mathematicians, instead of artists, would be leading creative fields, but history proves otherwise. At the end of the day, creativity is about imagination, expression, and originality, which are things math cannot generate. Math is like grammar in writing. It helps to structure sentences, but it doesn't create the story. Just as how great writers don't need to focus on grammar to be creative, great artists don't rely on math to be innovative. For these reasons, we have won this debate.
Proposition with?
Good evening. People say math is no help when it comes to art or creativity, but really, it's the main reason. As my group members mentioned, Leonardo da Vinci used math in all of his art pieces. Think about this. If not for math, what would you use to draw? You would just have scribbles, correct? Aren't shapes math? If you were to really get into it, you need math for multiple reasons in art. My fellow group members mentioned there are angles, proportions, scales, symmetry, geometric precision. All of these and more is math. These are also things used in the so-called art, right? Although you can just draw a tiny scribble and call it abstract art, is it really art if it doesn't include mathematics? Well, nowadays, anything can be art. Personally, art isn't just looking at a canvas, paper, or a sketch pad and drawing lines. There is way more to it than just that. If you were to draw, don't you need a ruler for your straight lines? Don't you need a compass for your perfect circles? All of these are also mathematical tools. You need measurement, precision. What could you do in coding without math? Really, what would you do? The real question is, why would you talk about math not being part of creativity if it was the main reason? The opposition team spoke about if math can really open your mind. Well, it actually does. Did you think about how the items are made to deal with your art? Yes, art can help you with creativity, but really, does this art give you as much as an open mind as mathematics can? Thank you.
Mr. Speaker, may I make a statement actually?
No, please. That is the end of the debate. Thank you.
That's unfortunate.
Welcome back to the post-lunch session of International Day of Mathematics, Combermere School, Waterford University. And let me apologize for the brief absence from the studio of my colleague, Mr. Michael Small, who's gone to create some footage in the chemistry lab where to do some other interesting things. We're going to jump right back into it. You've seen some of this before, the footage from Euler's discovery from the second form. So now that it's fresh, let me give you the remaining footage of that. Take it away, John.
Hi, good morning. We are here with Ms. Pemberton, who is the mathematics teacher of Form 2F, and she will give us a little bit more information on the activity that this form is engaging in for the International Day of Mathematics at Combermere School 2025. Ms. Pemberton, tell us about this activity.
All right, so the activity is on Euler's discovery, where the students are engaging with some manipulatives, which you will see in a bit, and the students are going to manipulate the nets that they were given into solids. The activity also asks for them to do some discovery on the relationship between the faces, the vertices, and the edges of a solid. All right.
All right. So how would this type of activity help to promote creativity and the understanding of mathematics in your class, you think?
Okay. All right. So firstly, some students are visual learners, and for the students who the abstract mathematics is often challenging for them, it gives them an opportunity to engage with the manipulative. And so the things that are usually a little more tricky in terms of discovering the amount of faces that a solid will have from just looking at it on paper on a 2D surface, it gives them the opportunity to interact with it and physically count, which is often easier for lots of them. Additionally, in the future, lots of persons are now into DIY and so on, and so understanding how to manipulate shapes and so on could prove helpful depending on what they are into. And in regards to the creativity and design, again, the diversity in terms of the solids that they would have interacted with can also influence, to my mind, the types of designs and things that they foresee in DIY projects.
Yes. Okay, wonderful. So perhaps we can go around your class and we can take a look at some of the students actively engaged in this Euler's discovery. So let's learn some more about what's happening. So we have one of the students of Form 2F here with us, with me. So she's going to share a little bit more about what she's doing and how she's engaging in this particular activity.
I believe that this is helping me understand it more with the geography of the shape, and it helps me embrace my creativity and artistic needs, because some people don't understand it with just working, and doing it physically helps a lot more.
So what shape do you have?
I have a cube.
Okay, so you're all practically finished?
Yes, please.
Okay, wonderful. So we have another young man of Form 2F who wants to share on his activity.
So this is, I think this is, what shape this? I think this is a diamond or a diamond, and my friend Selena Eiffel helped me with it. So yeah.
So y'all were working together, and that's what this activity is about too. Not only discovering as an individual, but working together as a group and as a team to get it done. Thank you so very much.
Yeah, I would like to say that all my good buddies at this table also helped me.
Okay, great, wonderful. Here's another young lady of Form 2F who wants to share her feelings and thoughts about this activity.
sometimes I'm not able to understand by just looking at the paper. So when I actually get to build things, it's easier for me to understand it.
So manipulate so that you can see it better.
Yes.
Okay, wonderful. Do you have any idea what shape this is? What solid this is?
I'm pretty sure this is the dodecahedron.
Thank you so much. All right, so we want to say thank you to Form 2F and thank you to Ms. Pemberton for helping us to appreciate for International Day of Mathematics the activity on Euler's discovery. Thank you so much.
Welcome back, welcome back. We are live here in the studios of Waterford University, also known as the Combermere School, where the time has moved on to 12:49. Let's continue with a little bit of historical trivia. On January the 9th, 2023, a team of 3 Combermere students took part in the inaugural Regional Mathematics Olympiad hosted by the Caribbean Science Foundation. While not advancing to the finals, the students lauded the experience as a valuable one, indicating that they will be willing to try again when the Barbados leg of the competition takes place. They also provided useful information regarding other opportunities available for them in the pursuit of tertiary education. This is International Day of Mathematics, March 14th, 2025. And we're going to dive right into another segment. And this is a lovely video produced by Enuela Oni. It's called Directing Numbers. So I'm going to ask John to take it away in the studio and let you see this wonderful video. Take it away, John.
Right. So, directed numbers with multiplication. You know that D and M that your math teacher told you to memorize? Well, I figured out a way that will not only remove the stress of memorizing it, but will also give you a new perspective of math. Math is not just a subject that you have to learn that eventually get frustrated by and end up getting a 73 on the test, but it doesn't bother you depending on what gives your mom giving you in class. Or is it just me? Math is the abstract science of number, quantity, and space. And that's not even a long definition. That's a short one. It was too easy to do the long. Anyways, without further ado, let's get into it. So I want you to imagine minus as your enemy and plus as your friend. Okay, here's an example. Minus times plus. Remember, minus is your enemy and plus is your friend. So the enemy of your friend is your enemy. Because whoever messes with your bestie, you mess with you. Right? Still don't understand? How about another example? Minus times minus. Remember, minus is your enemy and plus is your friend. So the enemy of your enemy is your friend. Because both of you are on the same side, right? Let me give you one more example. Plus times plus. So remember, minus is your enemy and plus is your friend. So the friend of your friend is your friend. Because whoever's on your bestie's side is also on your side too, right? And that's the whole game. Well, quick question. What is plus times minus? If you got minus, then you're absolutely correct. Well, I hope this was helpful and you enjoyed this video. Please note that there are many other ways of doing D and M, and do not just restrict it to this video. Thank you guys for watching, and as always,
Welcome back, and let me welcome back Michael from his stint creating some content. I also need to remind you guys that Mr. Michael Small has raised several hats at this institution on a regular basis, but this period is actually quite intense. So Michael is not only heavily involved in the creation of the International Day of Mathematics program, but Michael Small is also, need I remind you, the head of our physical education department. Need I also remind you that Combermere School are the defending champions in BSAC in both boys and girls. And need I remind you that a huge target has been placed on our back. So this man has to defend. So Michael, how are you looking for BSAC?
I would say at this stage we're looking pretty good. You know, the thing about competition is it's on the day.
Yes, right.
Right? So I could sit down here and make predictions, which I'm not going to do.
No, you never do that.
Because I don't do it. But I'll say that Mr. Marie, our coach, I have the fullest praise for Mr. Marie. Right. I have a good department to work with. And you asked me earlier, how do I do it? As I said, I work with a great team. And I mean, at Combermere, we have this concept of Team Combermere. Yeah. And Team Combermere doesn't just talk about the sporting teams. Any team that represents Combermere is part of Team Combermere. And team,
just like today.
Right. Team and if you want to break it down, together everyone achieves more. That's what we're doing today.
Wonderful words to live by.
That's what we're doing today.
Wonderful words to live by. Now we're going to dive right in. We have so much footage. We have footage on the treasure hunt to show you. We have a slideshow of the posters that were created. And we have also kite flying coming up. And we have an interview with the coordinator, that coming right up. But right now, Michael, we can go into Shamanda Arthur's footage, and yes, she has a video called Statistics. So let's take it away, John. Shamanda Arthur Lashley.
Statistic, yep. Statistic, yep. Yep. Statistic, yep. Statistic, yep.
First off, what is statistics? Statistics is the study of collecting, organizing, analyzing, and interpreting data. There are two main types of statistics: descriptive and inferential statistics. Descriptive statistics is the branch that involves summarizing, organizing, and presenting data meaningfully and concisely. Imagine looking at a large set of numbers in front of you on your desk. You wouldn't have a clue as to what you're looking at. Descriptive statistics helps break down that large set of numbers into information you and others can easily understand. Examples are pie charts, bar charts, mean, median, mode, and inferential statistics. Inferential statistics is the practice of using sample data to draw conclusions, predictions, and test hypotheses. Imagine selling drinks at a primary school, but aren't sure how much of which flavor you have to make. This branch of statistics helps you predict or estimate the amount you may need based off of previous sales. I asked 44 persons ranging in ages from 7 to 56 what their preferred snack was from the list of snacks given. Here is the data collected. This is a graph that I created using the data. Looking at this graph, we can tell that the most preferred snack is cheese sticks. Thanks for watching.
Statistic, yep. Statistic, yep. Yep. Statistic, yep. Statistic, yep. Yep.
Feel about you there.
Oh man, yeah man, lovely.
You ready?
Thank you very much, Michael. We got some stuff lined up. We got the scavenger hunt footage to show you. We got the kite flying interview for the coordinator, and so much more. How do you think?
I'm looking forward to it, but I have to throw a question at you, because you've been throwing all the questions at me. So I need to find out from you, what do you think about the day so far? How has it gone to you?
Oh man, I found that the effort that has been put in by you guys is paying off. It is going seamlessly. You know, you never know with gremlins. You never know what will happen. But so far, so good. I am so thrilled to be here, Michael. Anytime the phone is picked up and you guys call me to do anything, this is why, like, I'm working with you in this studio has always been a pleasure. So no, this has gone very, very well for me, Michael. This is euphoric for me. Coming back to this campus, seeing it, feeling the vibrance, watching these kids just interact at lunchtime. This made my day, man. This has made my day.
I'm very glad you feel that way, David.
Very much so, very much so. So we could go right into the footage that we've got for that scavenger hunt. This ought to be really interesting. John, take it away.
So I'm here with Isaiah Hines and Form 3A.
Yes, please.
And they are currently engaged. I know you can see some of the students in the background in a particular activity for the International Day of Mathematics 2025 right here at Combermere School. So Isaiah, can you tell me more about what this activity is involved?
So this scavenger hunt is basically to help us all learn more about math and help us with our upcoming exams, teach us, well, maybe help us with some weak points in our mathematics and just help us get better to be the best we can at this Combermere School.
Okay, great. So some of the clues then involve things like what?
Things like related to math, so like concepts like square, shapes, angles, addition, subtraction, modulus, that sort of thing.
All right, wonderful. So I won't stop you, Isaiah, from getting back to your group because I know it's a competition. So all the best to you on your scavenger hunt, Isaiah. Here with another student of Form 3A, Devesh, who's going to share with me about this activity and how it's helping him learn and understand mathematics.
So it helped me with my studying and remembering the formula of trigonometry and the angle elevation.
Okay, wonderful. You're working with your group. How far is your group in terms of getting all the clues?
We finished.
Y'all are all finished?
Yes,
So
ma'am.
what's next? What do you have to do next? Go back to your class and give the teacher?
I'm not sure, but I don't know who to hand it into.
All right, I noticed you have a tablet in your hand. You had to take evidence of these particular things that you had captured the clues?
Yes, please.
Okay, all right, so your group is all done with that as well.
Yes, ma'am.
So thank you very much, Devesh. And have a wonderful mathematics day.
You too.
Thank you. So I'm here with a student of Form 3B who is now engaging in the activity for the scavenger hunt activity for the International Day of Mathematics. Elan, how is this activity going for you and your group?
This is going really well so far, but so far this is traumatic.
Okay.
This is really stressful, but we're doing good. We're doing good.
In what way is it traumatic and stressful?
We can't get our picture taken.
Okay, fair enough. So you have to get photo evidence.
Photo evidence of all of
having
our
done
locations,
the
yes.
clues. Okay. What type of mathematical concepts are part of this scavenger hunt?
I've seen angles of elevation and depression, but I haven't seen the rest of the paper.
Okay, all right. Yeah. Thank you and all the best to your team.
Thank you.
All righty. Thanks. And back here in the studio again, I caution you, Michael Small is wearing several hats today, but he is the wind beneath my wings. And speaking of wind beneath the wings, the kites have been made and they are airborne. And Mr. Small has gone there to get some footage on this wonderful experience. So we continue in the studio just alone for a few minutes. And let me just conclude the historical trivia with this final paragraph.
In 2023, the rollout of Combermere School's celebration of International Day of Mathematics saw the formation of a cross-faculty committee, which also includes 6 former students and a member of the support staff, in keeping with the theme Mathematics for Everyone. The activities and competitions can often seek to celebrate the unity of mathematics in all areas, while providing students with non-traditional avenues to express themselves mathematically. That, in a sense, is exactly what's happening today. A cross-fertilization of several faculties at University of Waterford, which have come together to produce a wonderful International Day of Mathematics. I'm going to toss it back to John again, because he has some footage of the slideshow, which was a really intense competition as well too. So we have footage of that slideshow, which we'll get into right away. Take it away, John.
matter how hard the sun beat down, is not a frown. We face does just glow. We grow to flow from past earths to past times as ice blocks collide with liquids that smile across lips as we sigh. Satisfied, we rise like blades of grass pushing past concrete on sidewalks. We bump and dodge any pothole old enough to slow our roll. We know too much about roads as I steer across every road and gap that connects back to family and friends. There's no lack of decoration that paints my island. The chatter of the language, coloring the voyage from beach lines to Bridgestone lines. The rhythm of laughter, a part of a broad street of culture. Dialect destined to identify, whether it fly from a mouth or from a piece of paper. It's a foundation of fun. Spirited sparkles when the sea welcomes the sun. A horizon of possibilities that reveals no matter what ground my foot pun. I'm reminded of home when I feel the sun. matter how hard the sun beat down, it's not a frown. We face does just glow. We grow to flow from pastors to pastimes as ice blocks.
Back live in the studio with my main man, Michael Small. Michael, we got a guest in the studio. Tell us who he is.
Peter Skeet, is it right?
That's right,
Yes,
yeah,
and he is the guy who would have come and helped our students to make kites and you know, stuff like that, because you know that is a dying art in Barbados, kite making.
Sad.
You know, when I was growing up, you had to learn to make a kite,
make your own
clamp
kite.
cherry glue and all that.
Clamp cherry, man, yes,
that
of
ain't
course.
happening now. So Mrs. Skeet,
And bread
come in
paper,
here,
the lady.
come in here and tell me what was your initial thought when you were invited to do this.
Well, I was quite pleased. Obviously, I've been involved in youth development for the last 29 years. I'm the Youth Commissioner working in the Ministry of Youth, Sports and Community Empowerment. So then Dr. Leida asked me to come, of course. I didn't have a second thought, really. It's an effort to give back. It's an effort to inspire young people and show them elements of our Barbadian culture and heritage. As you mentioned earlier, it's a dying art, and these are things that we need to preserve as part of our intangible cultural heritage.
Lovely. How has the enthusiasm level been here at the school?
Oh, fantastic.
Wow.
The evidence is clear.
Yes.
I mean, the youngsters are having a wonderful time flaying what they've just produced. This is a good sign. The art is well for the future. Even at a school like this, people believe that these type of institutions only cater to academic development. But the fact that you can have youngsters here who are strongly academically inclined still want to be involved and preserve elements of our culture.
Children, and they need that, yes. That's wonderful to know. So what kind of success have they had on the field of play?
They've been flying, and that's a good sign.
Yeah, very good. So the traditional kite making that Barbadians are accustomed to, the rum kite. Let's hope that doesn't die. You know
Yes. But there are various types.
Yeah.
As you mentioned, we're growing on the trash bone kite.
Yes.
Elements of the sugar cane. You go into the fields, you know, get the trash bone, and you create that from a newspaper or something. Then you move into plastic bag arrangement, and then what we call the PS kite, which comes in various forms.
Right.
Kite paper, the very soft bread paper, which has a white coating, and then you are able to get the many different styles, patterns, the star diamond, the capella, and so on and so forth. But I tend to favor the more harder trace and paper version. That's a version that coming up from Holisel, the folks who live in Paynes Bay has specialized in that element of kite making, the trace and paper. It's more sturdy, it's more sustainable, and it allows really for even the elements when it rains, it's still able to fly, and it carries a wonderful picture in the sky.
So I have a question which I'm sure viewers at home and all or anywhere else. The connection between kite flying and mathematics. What's the connection?
It's an interesting question. You've got to be able to measure.
Yes.
To ensure balance. The kite, the square kite carries a certain balance. If you don't have the measurement of the crossbone correctly, then the kite, it would be difficult for it to fly.
Right.
So balance, measurement, you must have have that there. So there's definitely a
So
connection.
there's an
to
element
math.
of precision and
Precision,
specificity.
Yes.
Okay.
But how about the geometry, the loops?
Well,
the angles.
Yes.
All of that is important, because if you don't have the correct loop, then it's going to express challenges in flame as well.
Only as I grew up and became an adult did I actually recognize the value of the tail in terms of the stability. So even all that, there's a physics involved in that, and mathematics involved in that.
Because if your tail is too short,
Yeah.
then the kite will spin. If it's too long, it's not going to fly perfectly.
Right.
So in all this coordination, as I said, there's balance, there's geometry, there's all the components of it.
Pete, I got another revelation, and that is that you taught me something just now about the contribution of the Painsbury folk.
Yes.
And this is history that I never knew.
Yes.
Tell me a little more about
As a matter of fact, if you travel through Barbados, as it relates to kite flying, you will not see the trace and paper version kite no other part of this country. And it's the trace and paper that you use in art, and it's a ordinary brown paper that you wrap things in the story with, right? And there's evidence to suggest that the trace and paper kite, the bull is much louder and carries a more sweet sound than the ordinary versions of bulls, and the sight of it in the sky is very, very appealing, very, very appealing to the eye.
When you can write your book? I'm telling you, I'm learning some things here, and I thought I knew a little more about kites than I thought I did. I really did.
But I had to get into it. I mean, when I was a little boy, my dad was a carpenter, and he walked around with kite bones in his bag for a long time. So I had to learn. I had to learn the art. So from age 9, I was making my own kites, and then as I got to age 12, I made a significant amount of them and sold them to residents in the community to earn some well-deserved cash. As you get older, you then conduct training to young people. I've done a series of workshops within the community that I have geographic responsibility for hands over the years. Teaching youngsters the art of kite flying.
So what has the response been to that? I mean, as I said, it's a dying art. So you're going into communities and encouraging kite making.
Yeah, it's still very much a good art within the Gainesville space, even to the extent that the noise emanating from it is cause for concern to some residents.
That's true.
Even at that level, you have to intervene to ensure that the safety and the stability of the residents are not compromised by the culture.
And of course, you've got restrictions around the airport, especially since commercial flights are so prolific now. I got a question for Michael. Michael, tell me how you felt when you launched your first kite you make and it fly.
I did not make my first kite. I bought a kite, or a kite was bought for me, and I felt real good when it went up in the air, and I was able to maneuver it. But I have never made a kite in my life. I can honestly say that.
You're the candidate.
No, I don't think at my age now I need to think. But I'll say this here, right? Watching people make kites back in the day, I was fascinated by it, right? And I'm not the artistic type, so I wouldn't really see myself making a kite. Give me a kite to fly, back in the day, that's what I would have done. But I appreciate the fact that there are people who are skilled to make kites and do what this gentleman is doing to carry on the art form of making kites.
I have never been able to wrap my head around the precision and the pasting of those patterns. I have never been able to. And the tools with which they work are not the most sophisticated, but yet they can actually make a perfectly balanced pattern.
It requires discipline.
Definitely.
Patience.
Wonderful talk with you, Peter. I think it's been absolutely wonderful. I am going to press you, because I know you're working for that historical book, I'm going to press you for it.
Yeah, the Painsbury version.
The Painsbury version, yeah. Thanks very much.
No problem at all.
Thanks, Michael. John, I'll take it back to the studio for some messages from our sponsors.
cheese is wrapped in black and gold. It is called by name proper cheese. Cheese, dumb bread. You hear what I say? The best cheese is proper cheese. Now 15% off. Ask for the proper cheese at A1 Supermarkets, Carlton and Emerald City.
Emerald City and Carlton.
Proper.
Samantha's a florist. She works day and night. And this year, she got a new four-wheel drive. But life is uncertain and roads can be tough. And one day her route home was not long enough. Then along came a promise of fortune to change, fast, fair claim settlement, and service that saves. So Samantha, now revved up with answers in tow, can look to the future with worry no more. CGI is here. Let's work it out.
Welcome back to the studio. And Michael, we've got a very special guest in the studio. Introduce this gentleman for me, please.
We have the principal of the school, Mr. Robin Douglas.
Thank you, thank you, thank you.
So, sir, one of the first questions I will ask you as principal of the school, how has the day been so far for you? What day has it exceeded your expectations, lived up? Give me an idea how things have gone so far.
With regard to International Math Day.
Yes, yes.
You need to specify.
We weren't talking about anything else. We weren't talking about Math Day. Idea.
Idea. Yes, please. The day has been quite impressive and also very pleasing to me as an educator of 26 years who has had mathematics only to CSEC under my belt for that length of time, right? No, not including CAPE, but certainly as a mathematics teacher for this amount of time. I've had quite the exposure and experience conveying mathematics to students and hearing their concerns, the usual refrain of, what has this got to do with me, sir? How will I ever use this? And things of that nature. Given my perspective as a mathematics and physics teacher and the reality of mathematics involvement in every aspect of life and existence on the planet, then it is absolutely excellent to have the mathematics department of this most illustrious school, let us be honest, be involved and engaged in providing students with experiences that exemplify or show mathematics involvement in various forms of life, in various aspects of life. The kite flying construction, the worry competition.
That's ongoing right now?
That's ongoing currently. So we had a visit from a member of a subject coordinator from the CXC involved in mathematics, examination and assessment and so on, and she thought that there was an excellent amount of things happening, excellent variety of things happening within this for this day. So the summary of my perspective is that this is an excellent endeavor, an effort by the school's team, mathematics department and beyond, because of course there's always combined effort in getting these things done, and it heartens me that these efforts are being made to involve students in mathematics in a way that gives greater value and worth to what they learn in the classroom.
Mathematics being a part of their daily lives, and they're actually now seeing where it fits.
Yes,
correct.
yes. Some of the ways in which it fits. Mathematics instruction is not easy. As a mathematics, as I said, I taught mathematics for all of my career, in addition to other things. And other than the commentary from students about how this really relates to them, sometimes mathematics can be very abstract. It doesn't seem to have connection to reality. And so the authenticity of the instruction, meaning how connected it is to things in everyday lives, is not immediately apparent. And that can be difficult to get past, especially with a culture or perspective that pervades society. Mathematics is hard, I can't get do. Students would often talk about trick questions in mathematics, and sometimes we see those things on Instagram of if a truck was taking this amount of time to travel this distance, right? How heavy is the apple that was eaten by the student last week before they got in the truck? As evidence of how unable people feel mathematics is. And so those questions are shown to say, mathematics is always this kind of strange thing that they ask you questions that don't make sense. And I, in my mathematics teaching, would always tell students, there is no such thing as a trick question. We need to remove that perspective. I'm sure there are persons out there who watch this and saying, what's he talking about? But it is for us to understand that a lack of understanding builds, increases or builds greater lack of confidence in attempting mathematics, and that lack of confidence builds distrust. So that when you see things and when the student is engaging with mathematics questions and so on, they may feel, the teacher's always trying to get me with questions. I've experienced this. And so if anything that happened today can help erode those misconceptions, it will be a good start for us to build the kind of strong foundation that we need amongst our students regarding mathematics, pursuing mathematics, whether it is just at the fundamental level, because we know that all careers won't extensively use it, to the highest level where mathematics will be directly involved.
So tell me, so as a teacher of mathematics, part of your technique then would be to pique their curiosity.
Indeed.
So in other words, a problem is solvable, I want you to be curious about the problem. So that's part of the mechanism.
One of the things that is so important, because we have to admit that the bell is ringing, and that may be heard by our
That's fine. That's perfect. We talked about that before.
Right. We have to admit that there are ways in which mathematics is directly involved in our everyday lives. Yes. And so we do have to admit that there are some topics that may not seem to have any immediate relevance to things. But that's one of the challenges that can make mathematics instruction a richer, deeper experience, where the teacher gets to vary the methodologies, the pedagogy of the classroom. Yeah. They get to vary the set induction, as we call it, the introduction of topics. And it is so powerful when you can take mathematics outside of the classroom, because mathematics classes are often, we are in the rows and the columns, and the teachers walking around or sitting at the desk, and you call people to say, okay, what problem you have? No, can we involve going out into the environs of the school and engage in whether it is an application of Pythagorean, theory or trigonometry, which are connected and so on. And then can we look at cross-disciplinary of applications? So, yes, we have other subjects, and one of the unfortunate ways in which we teach is that we have separate disciplines, and this persists a culture in our students that, that is that, and this is this, so these are not connected. However, measurement and volumetric analysis in chemistry, various measurements and so on in industrial technology, the use of linear programming in economics or business. Forgive me if I slightly incorrectly call that, but business applications for algebraic expressions. And so you see what I'm saying? Yep. So there is not just the option to just go outside, but there is the option to also enrich classes between subjects by teachers indicating, well, here's the mathematics part. And when the children say, oh no, then you can say, no, don't be upset. Let's see how this works into what you've been taught.
Brilliant, brilliant. Now, today's Friday.
Yes,
when I walked into your office this morning to say that I was here, we ready to start, you looked as though you were ready the day's work. Are you gonna take some time and walk around and just breathe in this mathematics era and all the distance? You can take some time to do that?
I guarantee I'm going to do that. I'm going to go and check out the guys flying the kites, right? I'm going to I'm going to go and have a look at the worry. Yeah. I'm to get into it myself. I love me a board game, so it would.
But suppose one of these sports farmers beat you though.
That's quite fine. Right. There's always time for the student, right, to become a master, right? Right. So certainly, I'm going to definitely take it in.
Thank you so much for this time. Thank you very much, Michael. Wonderful interview.
Yes, I'm glad to hear the things he expressed, right?
Absolutely.
And as I said, I want to keep harping on this, the fact that the different departments, so if I want some bougie, the faculties have come together.
On the campus.
On the campus.
Of the University of
Waterford. Have come together to make
correct.
this day a resounding success.
Yes.
I really want to drive home that point.
Yeah. Wonderful.
Because you cannot just think about it in a singular thing, just mathematics. Different departments have come together.
And they
to
show
make
the
this day.
relationship.
Yeah.
Wonderful. Thanks very much, Robert.
Okay. Thanks very much.
Yes. Okay.
Of course I know what I'm a math student. Of course I know the Pythagorean theorem.
I'm a math student. Of course I love problems. I'm a math student. Of course I use algebra in my everyday life.
I'm a math student. Of course I know 100 digits of pi. 3.141.9, this is pi.
I'm a math student. Of course I love calculus.
I'm a math teacher. Of course I'm always at work.
We're in junior school. Of course we love math.
To
Josiah Osborne is an upper sixth form student at Combermere who entered the poster competition as well as the video competition for IDM 2025. Josiah, what subjects do you do here at Combermere?
I do computer science, accounting, and pure mathematics.
Okay, so all subjects with numbers. Have you always been interested in math?
Yes, from a young age, I've always found mathematics interesting, and a bonus is that I was really good at it, and it wasn't something I really struggled to get.
Okay, and for the poster competition, your theme was mathematics and engineering. What was the inspiration behind that entry?
I've always liked engineering, but it wasn't a subject that I personally think that I could have done. So I wanted to, even though I couldn't do it, I wanted to showcase that you can do it by showing how simple math concepts like trigonometry and calculus is used in engineering. For example, they use angles to figure out how to plan things perfectly so it doesn't crash randomly. So,
Okay. So when I looked at your poster as well as your video, I noticed that both of them had very creative elements. You said that mathematics has always come easily for you. Would you say the same about creativity?
No, I've not really been an artistic person, but I really wanted to show the artistic side of mathematics. Because the way poster isn't really artistic, it's more simple, but it was something I could do. And for my video, I just since it was online, I could have planned for well, really. I could have done all the artistic things in one day, so it was much easier to put together than the poster.
Okay, understood. Can you tell us some more about the video entry, which was on row reduction?
Yeah, I chose row reduction to echelon form because it was a topic which was easy to explain, really simple, and I wanted, because it's also used in real life as well as real jobs, such as engineering. So engineers use it in circuit analysis, and computer science use it in algorithms. So I was just if anyone is interested in these jobs, you also use row reduction, and even the ones that in junior school can be anyway, your math in upper 6, this is this topic I'm going to come across, and I want to have an idea of what is right.
Okay, understood. You were mentioning to me how it can be used for school clubs. Can you share that with us?
Right. So, for example, in Key Club, they usually sell a lot of items, and they need to figure out, so if they have donuts, like pizza, they have to figure out, what do I price these items so that I can meet a certain profit target, such as $500, and you can use row reduction to figure out. Row reduction helps you to find multiple solutions, so you can figure out, I have to spend buy 200 donuts and price at $4, and for the pizza it's probably $50 and price at $6 to reach that profit target of $500.
Okay, so then instead of just blindly putting a price on the item, you ensure that you meet your target if you use this method. Okay, that makes sense. Well, thank you for having this chat with us, and I really wish you the best of luck in both the competitions that you have entered.
Okay, thanks so much. I really enjoyed it.
Hello. Today, we're going to talk about row reduction to echelon form. But first, let's take a moment to explore what row reduction is. Row reduction, also known as Gaussian elimination, is a step-by-step process used to solve systems of linear equations. The goal is to simplify the system, making it easier to find the solution. Perfect! Now that we know what row reduction is, let's dive into an example. Here, we have a system of linear equations. The first thing we do is write it in matrix form, then as an augmented matrix. From there, we aim to create a leading diagonal filled with 1s. To make this happen, we use row operations, things like swapping rows, multiplying rows by constants, or adding and subtracting rows. Once the matrix is in row echelon form, it becomes much easier to determine how many solutions the problem has. In this case, The equations have an infinite set of solutions. But here's the thing, row reduction isn't just a concept for math class. It's widely used in the real world too. Electrical engineers, for instance, apply it in circuit analysis to solve systems of equations that model electrical circuits with multiple loops or junctions. Computer scientists use it for algorithm optimization and machine learning. Economists also rely on it to model complex economic systems. So, whether you're solving equations in a classroom or designing algorithms in tech, row reduction is an essential tool to have in your toolkit. Have fun learning!
And welcome back. It is 1:42 in the studios of Combermere School, and this is International Day of Mathematics 2025. Michael, remember earlier in the pre-let session I alluded to the fact that we've actually done a jingle?
The jingle competition. You told me you looked at some of the stuff.
Let me tell you, when we don't have the footage that we would have liked of the jingle, let me tell you that mathematicians are a different bunch. They have done everything scientifically. I got the rules of engagement for this jingle. Let me read a few points for you, because I find it so interesting. The jingle competition is open to all current members of the students, must be submitted and shall not infringe on copyright. The jingle should not be more than 60 seconds and must not contain expletives. So fellas have to choose a genre of music very carefully. They can have multiple co-writers. All genres of music are accepted. Of course, the submission dates, etc. But it goes on, and these are the types of jingles that they are inviting. You have a fraction jingle. So this is mathematics, people. A fraction jingle, a geometry jingle. Let me tell you about the fraction jingle for a minute. The song is how to add, subtract, multiply, and divide fractions, emphasizing the need for a common denominator in addition and subtraction. Okay, that's the fraction jingle. The geometry jingle, a song that covers the properties of shapes, triangles, squares, circles, etc., and their formulas for area and perimeter. There's an algebraic expressions jingle, the song to explain how to simplify expressions, combining like terms and the distributive property. A probability jingle. And my head hurts me right now.
Probability.
A probability jingle. And other jingles. And there is a judging rubric for this competition. Michael, I had the chance to download some of the jingles, and I bet to sleep laughing at some of these. I can't go through all of them. But this is absolutely phenomenal. Students are so creative once you give them the chance. And this is mathematics jingle competition. It's something for the ages. So congratulations to all involved. And you've got something to do with it.
No, not really. Not in that aspect. But the creativity of the students we must applaud the students. You know, the last time I remember people did posters that showed how math is used in everyday life. I think somebody did a poster with going to the supermarket and shop, right? And there are things I'm seeing, or I saw then and seeing today too, that I never envisaged you could draw it to math. So this day is really a great day, and I would like to see this go on from strength to strength.
Thank you, Michael. And we're gonna have the strength for it, right?
Of course.
Right now, I'm gonna toss it back to John, and John has got some footage showing the collaboration of the geography department and the sociology department. So take it away, John.
The children raised together.
Welcome back to the International Day of Mathematics 2025 right here at the Combermere School. We are looking at an exhibit from the geography and sociology students at the school. And this young lady and these young people will share on their topic for this particular day.
Our topic is mathematics in demography, understanding population dynamics.
All right, so we're going to take a look at what you have in terms of how we can relate mathematics, art, creativity, and relate it to all the other subjects, including geography and sociology. So let's take a look at their exhibit. So help me to understand what I'm seeing here.
Now, mathematics plays a very integral part in helping us understand our society. So mathematics in demography helps us to understand population dynamics. Demography is the scientific study of human populations focusing on their size, structure, distribution, and changes over time due to migration, births, and deaths. So there are a variety of equations that help us understand factors that are in. So the first part of our presentation is mathematics in demography. Mathematics helps us to understand population dynamics. Demography is the scientific study of human populations focusing on their size, structure, distribution, and changes over time due to migration, births, and deaths. There are a variety of equations that help us understand how mathematics helps us in demography. The birth rate is the number of live births over the total population multiplied by 1,000.
All right, so then we can see some other rates. So you have the death rates, it's kind of the same thing.
Yes, please.
Where you're doing the number of deaths over
the total
TP,
population
okay.
multiplied by 1,000.
Okay.
The population density is the total population over the area of land. Then we have the immortality rate, which is the number of deaths in a certain year over the number of live births multiplied by 1,000. Then we have net migration, which is I subtract E over the total population multiplied by 100.
All right, so you can outline for me then, I can basically understand that when we are looking at the population of a country,
yes, please,
then these are some very important statistics that we want to take note of, or some important numbers that we need to take note of.
Yes,
because
please.
over the last couple of years, we recognize that in Barbados particularly, this birth rate here then has been very low.
Yes,
so
please.
this is how they would have done that calculation to
Yes.
find out. Okay, great. Thank you very much. So let's continue on to get some more information about clearly the population in Barbados and what's happening.
Today we'll be discussing about population pyramid in Barbados. As we can see from these two graphs, from Barbados 2010 and Barbados 2021, we can see a significant change. But before that, I want to let you know what's how it's projected. As we can see that a working population is dominant. However, we can also see that people are living longer as we go up. And population below 10 to 14 is very low as compared to working population, which determines as a dependent ratio. And which also tells us that the Barbados have an old aging population. I will hand it to Kimani.
Okay, thank you.
Continuing from what my friend said, we can look at the definition of a population pyramid. Population pyramids are important graphs for visualizing how populations are composed. When looking at a group divided by age, sex, there are three trends in population pyramids: expansive, constrictive, and stationary. Okay, population pyramids allow population structures to be presented in a way that makes the data easy to analyze and compare. They can be used to compare changes in the structure of the population over time. They allow governments and their agencies to project future population needs, such as health and education, and put appropriate plans in place to meet these needs. Population pyramids are split up in half, showing males on the left and females on the right.
So you can point to it for us so we
Right.
can better understand.
So we can see here, males are on the left and they're in blue, and then females are on the right in the pinkish reddish color. So the vertical axis is usually divided into 5-year intervals. The value along the x-axis can be raw numbers, but are usually expressed as percentage of the population.
All right, thank you very much.
No problem.
Alrighty, so I have been tasked to present to you on the dependency ratio. So first I will start with the example, which we have presented to the top. So the formula for this would be the number of dependents, which are the persons below the ages of 15, so 0 to 15, and then above the ages of 65 and onward, multiplied by 100%. So if China has 1,000 people under 15 years old, 1,000 people over 64, and 5,000 people between 15 and 64, then to calculate this, you would put 1,000 plus 1,000 divided by 5,000 and then multiply it all by 100 to give us a dependency ratio of 40%. Now, this statistic is important as it helps us to further develop a country by allocating social and economic resources for the elderly, like social services, healthcare, infrastructure, etc. Now, for the population composition, this is specifically describing in the population the differences in sex, in marriage, marital status, and age, education, occupation, and then the relation to the specific heads of the households. So in these ratios, we typically use the age-sex ratio and then the regular sex ratio. Now, the difference between these two is the age-sex ratio calculates the population varying by age. So pretty much the number of males of a specific age divided by the number of females of the specific age multiplied by 100. Whereas the sex ratio just shows the differences of gender in a particular population. So just male and female divided by that and multiply it by 100. So this ratio is important as it allows us to understand why certain species have specific ratios to analyze the social and health implications of a particular area. So this also, things like mortality rate, social and cultural environmental factors also influence this ratio as well. These statistics help us to more understand the social economic areas like workforce, population, healthcare, and education for both genders. Okay, wonderful. Thank you.
Good afternoon to all viewers and a happy International Math Day to all. So the area I've been tasked with is population growth rate, and population growth rate is basically a measure that shows how fast a population is increasing over a specific period of time. They help governments, they help organizations, for example, the Barbados Statistical Department, the Welfare Department, they help them to plan and allocate resources for development and economic policies. And ways statistics are used, for example, is like policy making. Governments use demographic statistics to create policies on healthcare, education, and housing. Another way it assists is in terms of migration, so the movement of people from one area to another. So for example, if they move from internal migration or external migration, so for example, internal movement within a country. So for example, I want to move from Christchurch to St. Lucie, that would be internal, and external would be moving across national borders, for example, from Mexico to the United States of America. These statistics, they help provide clear numbers and patterns to help important questions. So for example, where are you moving? Where are they moving? Or even how many people are moving to this place? So they help in terms of like building schools, building houses, hospitals, basically social support services. And that's how population growth rate ties back into sociology and as well as mathematics.
Wonderful. Sounds good.
Hello, good day all. Happy Math Day. The area I am tasked with is birth rate, population density, and fertility rate. So let's start with the simplest. Birth rate, also called crude birth rate, is the number of births per 1,000 people in a population in a given year. Birth rate statistics are very important because they provide critical insights into population growth, as my associate would have mentioned, and also critical insights into age structure and fertility trends. It also shapes infrastructure planning, policy, development, and economic strategies as well. It also helps to address future challenges related to workforce ability, social services, and sustainable resource management. The death rate, also called the crude death rate, is the number of deaths per 1,000 people in a population in a given year. It is calculated by number of deaths in a total number of deaths divided by total population times 1,000. Now, this statistic is important because they provide key insights into population health, mortality trends, and life expectancy, helping identify public issues and healthcare needs. They also influence policies on healthcare systems, disease prevention, and social security, while also adding understanding. Now we move on to population density. This is much more simple. It basically refers to the number of people living in a specific area, usually expressed as a number of individuals per square kilometer. It measures how crowded a place is by calculating how many people live within a given land area. it's a way to compare how densely populated different parishes and states are. This is according to McArdle in 2013, and population density can be used to make population estimates. The units are, as seen here, people per kilometer squared. Occasionally, the units might be people per square mile. It helps to identify overcrowding or underpopulation in regions. It informs urban planning, resource allocation, and infrastructure development. It highlights migration patterns and environmental impacts as well. Now, the two of these are actually very important, and they're relevant to Barbados, but I think this last topic is the most relevant to Barbados currently. It's the Barbados birth rate. As you know, as seen here also, the birth rate has actually been going down in recent years. And we have, correct me if I'm wrong, the second lowest birth rates, only beaten out by places like Japan. So this is a very relevant topic for the country we live in. So the fertility rate measures the average number of children born to a woman over her lifetime. And it's very important. It helps because it predicts future difficulties in labor and healthcare. The population growth is a ratio of 2 to 1 per women. Above this encourages population growth, and below this encourages population decline. It also helps with the economy. High fertility rates boost the workforce. Low rates lead to an aging population, as we have constantly heard within Barbados as well. And this can also lead to a variety of issues as well, like the need to build more geriatric centers, and less funding going towards educating the youth. So it is a serious issue. And this fertility rate is also important for healthcare and policy, as it helps the government determine if we have a young or aging population able to create children, funding, and geriatric care. So, yes.
Wonderful. This is great information. So I also see that there's a section here on the effects on living standards and how that can assist us, and how all of what was discussed before can then help us in our understanding of demography.
Yes. So this poster will be specific to points that would make population density and knowing the population density of a particular area important. But being honest, all of this information is very important to all of these statistics mentioned previously. So all of the equations that you have can be helpful in each of this specific information. So urban planning and infrastructure, you heard that was mentioned earlier in different points about dependency ratio, population growth, etc. If the population density of an area is high, and it would require more housing, more roads, more transportation, and public services. If it is low, we may require more things like access to schools, hospitals, and businesses. So knowing this information would be very key. It also affects on living standards. In a high-density area, we can provide more efficient public transport, modern infrastructure, social services, and just improve the overall quality of life for the people living in that particular area. But the high-density areas could also cause problems such as overcrowding. We could get slums, might have issues of high rent or pollution, just inadequate public services overall if we have a lot of people in a particular area. Now, economic growth and job opportunities. Densely populated areas typically have more businesses, more industries, typically more employment opportunities. But as we do know in Barbados, sometimes there's an area of overpopulation in the workforce as well. Sometimes we have issues with not being able to find a job. Well-qualified people coming from university are not able to be employed just because the workforce is just so populated. So for health and sanitation concerns in high-density areas, you could imagine that there would be diseases spreading easily. I mean, issues with cleaning up waste and so on could be very hard if the country doesn't manage that very well. For low-density rural areas, they may lack sufficient hospitals and healthcare just because they may have not seen very important by the government. They may not have gotten the funding that they would require for the persons that do live in that particular area. So for impact on resources and environment, for the high population density, it would increase the demand of water for food, for energy, for housing, just overall affecting maybe the living standards of each person just because everybody is trying to split resources in a particular area. Similar, tapping back to Barbados, we know this area sometimes happen with Bridgetown or St. Michael, where you might be looking for a place to find a home to build or something like that, and that particular area just isn't suitable. It does have a hospital, it does have hotels and healthcare and supermarkets, gas stations, but it would lack the necessary resources for you to live there safely. So overcrowding can also lead to deforestation, air pollution, issues with waste management, and just overall impact climate change. So this was our presentation specific to the mathematics in demography. I hope you was able to enjoy it. And lastly, we'll show you a small game that we found that we'll be able to play to learn more about this topic.
Okay, let's go.
All right, so I will be the host. I will allow my colleague Rocher to choose one of these options.
All right.
All right, so you do have the option to choose between general population growth, demographics, demographic transition, age structures, solutions to overpopulation.
All right. I'll take demographic transition for 300.
All right, so the stage of demographic transition in which the population size decreases and there is 0 to negative growth.
That is stage 4.
All right, so would you be able to answer in the question? You could say what is stage?
All right. So with the demographic transition model, typically the time where population growth really kicks up is about the second stage, because that's where technology is starting to really improve and living standards are really advancing. So people will start gaining more access to things like birth control, healthcare, and generally there'll be less people dying trying to give birth to kids and less kids dying in general, harkening back to birth rates.
All righty. So your answer for this will be what is stage 4?
Yes.
All righty. So the answer that they have is what is the post-industrial stage, which would make him correct of stage 4. Correct.
Okay.
All righty. We also have another person coming to play. Arjun, you could choose an option.
So I would go with overpopulation 200.
All righty. Solutions to overpopulation 200. Your question would be public advertising, increasing education for women, economic incentives, and legal punishments are all actions that governments take to try to do what?
It could be more like it's more like related to like crime, because the more the because increasing education, because there's a lot of discrimination of women around the world, mainly in the developing countries. For example, in Pakistan, where only like 2% of women are educated, and it could be the one of the reasons.
So your answer it would be to mitigate crime in particular areas?
Yes, please.
Alrighty, so the answer is what is to limit population growth. Now to explain why this answer will be accurate, is just when we educate women, we allow them to, educated women typically decrease the amount of births they have, hence why Barbados' birth rate would have decreased over the years. We started to educate more women, we started to implement them in more jobs and so on, give them more opportunities. Therefore, they're occupying themselves with lives and so on, and more educated women typically understand how expensive having children is. Public advertising, they also advertise about birth controls, about condoms, about safe sex, just limiting the overall growth rate of a particular area. So that's why the answer would be correct, but your answer was still very understanding and knowledgeable. Thank you very much for playing.
I mean, there's nothing more to say than this has been a comprehensive presentation. This exhibit has showcased the skills and the knowledge of the students, of the geography and sociology students at this school. And I think our future is in good hands. Thank you very much.
Five after 2 in the studios of Combermere School, Waterford, International Day of Mathematics 2025. Earlier when I was winging it alone in the studio, Michael had been to the chemistry lab to actually examine what was happening. What was it there, Michael, that you got to put it on?
We saw some soaps that were made of different things, different materials. And it was quite interesting to hear Mr. Gerald Phillips explain what went into the process of making these soaps. So
Wonderful.
hopefully that's what we will see next.
Yeah. Okay, John, let's hear what Gerald had to say about soap making.
Good afternoon. We are here with Mr. Gerald Phillips, retired teacher from Combermere School. He's here to explain what's going on here with these coconut oil soaps. Mr. Phillips, can you tell me exactly what's going on here?
Okay, well, what we do, we're going to take what effectively is coconut oil and change it into a soap. We're trying to do an organic product, absolutely no petrochemicals whatsoever. The reason we're leaving out the petrochemicals is because the association with allergies and carcinogenic properties, etc. We then also can use things like iron oxide to color the soap, or in this case, we've used charcoal as well to produce a beauty soap, if you like. And we've used some lemon essence to produce something that will give you a little bit of a smell when you go into the bathroom. But once we do the coconut oil soap, one advantage is that it lathers in hard water, like we have in St. Philip and certain other parts of the globe. But the addition, in addition to this, I use coconut oil because I sail, and coconut oil will lather in salt water.
The question may be asked by those looking on, what does this have to do with mathematics?
Well, in this case, we prepared a particular formula, and we worked it out for 100 grams, but they needed to make more than 100 grams. So the quantities scale linearly. In other words, if they want twice as much, they would multiply it by 2 to get for the 200 grams of coconut oil. And in terms of ratios, if you were to look on the board, you will find that there is a ratio of sodium hydroxide to coconut oil to water that has to be maintained, otherwise the reaction will not proceed as planned.
So it would be safe to say then that this is a pretty specific and precise operation.
Yes, it is. It is chemistry. And Dr. Boleno will testify to that. And if you do it wrong, you get into big trouble. For example, if you put in too much sodium hydroxide, you run a very, very serious risk of damaging your skin permanently. And if you put it on your face, you could blind yourself. So you do actually have to know a little bit of chemistry and be sure that you've measured everything properly.
Thank you, Mr. Gerald Phillips.
Welcome back. Michael, can you believe it's 4 hours that we've been here?
Really,
Gone.
it doesn't feel like that. What I want to say right now, though, I was involved in the inaugural IDM 2 years ago. I think I can risk to put out my neck and say that today has topped 2023.
I have no objection. You say that, sir.
You know, I mean,
really gone through.
the coordinators of this program must be complimented. There's no praise too high for all of those involved in the production of this here, and at the risk of not calling anybody's name, I would
So
just
you
stick.
forget- you don't
Yes,
forget
you know,
anybody.
I'm prone to senior moments at this stage in my life, so I don't want to do. You know, I don't want to call names and then forget anybody. But seriously though, a production like this, it calls for a lot of teamwork, and that's what we've seen today.
Absolutely, Michael.
They coming together.
Maybe there's an argument for actually showing what goes on behind the scenes or something. Because you guys are exhausted. You guys have been working at this for several weeks, and in this week alone, you must have clocked about 50 or 60 hours on this alone. You guys are exhausted, and let me tell you, no praise is too little for you guys. You've done a remarkable job.
I am happy, very, very happy to be part of something like this here. And it's all giving back to Combermere.
Wonderful.
That's the biggest thing for me, giving back to the school.
Wonderful. We got a bit of footage lined up from the Worry competition, or actually no, it's an interview with the Worry aficionados. So I'm going to toss it back to John, and let's have that interview, and then come right back into the studio. John?
Good afternoon, and welcome to Combermere's celebration of the International Day of Mathematics. With me today, I have Mr. Rollins, who is one of the persons in charge of the Worry competition you see going on behind us, along with Mr. Mears and Miss Hinkson. And we're going to ask him first off what motivated the inclusion of this competition in the celebration of the International Day of Mathematics.
What motivated the inclusion of Worry into today's events is that on Culture Day we saw how enthusiastic the students were to participate in the game. And what I like about the game is that you have a nice mathematical content to the game. So although the students were there for the historical event or the historical nature of the game, we saw a lot of math in it. When you're playing Worry, it's a lot of strategy. You have to think, and sometimes you may have to lose a couple pieces in order to win the game. So how does that apply to mathematics? In mathematics, sometimes you may not be able to get your answer on the first try. Or if you're familiar with some of the greats of mathematics, is a guy by the name of Poyer, who says that there are different methods to use that we can use to solve problems. Using the Worry, you start with two competing tribes, and the idea is that you want to gather as much pieces from the opponent tribe as possible. However, one of the unique problems you still have to leave your opponent with at least one piece that he or she can play, which introduce a particular problem to it. So if you don't leave your opponent with at least one piece, then your opponent can win. So that means that at each point, you have to think about what you're going to do next. You have to apply your strategy. You have to write out your plan. And all that bodes very well for mathematics. When you're doing problems, and we have a nice, difficult problem, yeah? Nice and difficult. We had a math teacher, a math giant that was here to talk about stickability and the ability to stick and work at a problem. So Worry helps us with that. Helps us to think, strategize, and enjoy success too.
Thank you very much. Very comprehensive response. How many students do we have today competing in the competition?
Initially, we had 18 students. However, that has blossomed to at least 25 students. So we had a situation where we had to actually turn back quite a few students, or turn away quite a few students. But right now we have 18, but we have some of the junior schools participating in the kite flying competition who will be in shortly.
Okay, thank you very much. I think that we're in for a great competition. The students look quite excited and involved. So we'll check back with you and see how they have performed by the end of the session.
No problem.
Thank you very much.
The rules and so on by the end of the session. Oh, well, in the midpoint. In the midpoint, yeah.
Thank you very much.
Okay, you're welcome.
And welcome back. Michael, we're in the home stretch right now. Yes,
we
are in the home
are.
stretch. And we got queued up for you 3 wonderful videos. You're going to first hear from 2 wonderful young women who are going to describe, I guess, the origin and the development of something called the Royal Game of Ur. That's UR. Then we're going to hear from the creator of one of the jingles, a young man by the name of Grayson Belgrave, and I think he got one of the probability jingles, and his is called 16.66%. That ought to be a real interesting one. And then we got a video with Taryn Sutherland. So I'm going to ask John to tune them all up and run them back to back. John, all yours.
Today we're here with Ariane and Tegan, as well as their history teacher, Mr. Bannister, and they're going to be sharing some information with us about number systems of ancient civilizations that they learned in history class. Hello, everybody.
Hello.
Mr. Bannister.
Hi. Well, as I said, this is Tegan, it's Ariane. In their hand, you'll see a game that they made. I'll ask Tegan to tell us a little bit about the game.
So this game is the World Euler, and you play it by you have to roll the dice in your hand, have two of them per person, and you move the spaces depending on how many of the white sides are up. So that is for these four sides, and then the middle is called is like the battle field, where if you land on the same side in the same space as your opponent, you get kicked back to the start. So they are basically in the lead until you make it to these two spaces, and then you win.
Very good. Sounds similar to a game that we play currently. What's that game? Ludo. Very good. Also, children in ancient civilizations were pretty similar to kids today. Oh, very good. Can you show us what the dice look like?
So,
these are the white pieces that you talked about? Okay, all right. Are there tiles for this game or anything? Or?
there are tiles, and these are the things that the players put down to show that they're in space.
Okay. We see there's some stars. Are there special spaces? What's special about those areas on the board? There's safe spaces.
The stars are the
safe spaces.
Yes.
Okay, right. What's the line here? I can't be knocked home. Okay, very good. All right, thanks, Tegan. Ariane, I heard you're the master of the mathematical systems. Which two systems in particular did we look at?
The Egyptian-based 10 and the Sumerian-based 60.
Very good. Do we still use base 10 in our mathematics today?
Yeah.
So you said the Sumerians used base 60. Why? Why did they choose base 60?
Because they wanted equal answer without remainders.
And base 10 provides too many remainders? Right, okay, I got you. Is there anything else that they influenced?
How we tell time.
How we tell time? Okay. And what way?
The minutes. Like 60 minutes in all.
Okay. All right, so 60 seconds is a minute. Okay, very good. So when it comes to like circles, the revolution, they would have impacted that as well. Okay, very good. Ms. Ford, anything else you want to ask them?
Yeah, when you guys first started discussing math in a history class, what were your thoughts?
I can tell you from my experience, they look shocked because normally they would think that we're just looking at names and dates. So when we realized that they were exploring how children would have lived back then, one, it caught their attention, and they were also shocked that they were discussing mathematics. That was your experience as well? You're confused? Was it fun though? You enjoyed doing the projects in history? Okay.
Is the game something that you would introduce to other people so that they could play and experience it as well? Okay. Have you yet? Well, I hope that you do that soon, maybe on International Math Day, we can share this game. Thank you, Ariane, Tegan, and Mr. Bannister for chatting with us today.
You're most welcome.
Grayson Belgrave is a third form student here at Combermere. He is also the winner of the recently concluded Combermere School Talent Show. Grayson, when you heard about the International Day of Mathematics competitions, did you know immediately that you would be entering the Jingle competition?
Yes, please, no other option.
Why is that?
I really like music. I'm not too good at music theory, but I really like music. I like making music, I like listening to music, I like playing music. And that's pretty much why.
Okay, so how do you feel about mathematics?
I like mathematics. I'm just not that good at it. I'm not that good at math.
Okay, so do you feel like something like doing the Jingle could assist with your mathematics performance?
Yes, please, for sure.
Alright, your song is called 16.66%. Can you explain that?
I named it that because I was going to do a coin flip as the chance because it's for probability, but I decided to do a dice because I wanted to challenge myself. And the percentage for each side is 16.66, so it seemed like the most available option. Very easy.
Okay, and was the process of creating your song easy? What did you use to do it?
It wasn't too easy because it was a new software to me. I usually use Ableton Lite, but the device that I had that software on is broken, so I had to use BandLab. I wasn't getting paid for one of the subscriptions, so I had to use BandLab. I had to learn BandLab. It really wasn't that hard to learn. I understand why people use it, and yeah, it was pretty easy. And I like how the song came out, so I'm not upset about it.
Okay, it sounds like you like a challenge. You challenge yourself with the topic for the Jingle as well as using the new software. And I hope that you will be successful in the competition, Grayson. Best of luck.
Thank you.
You're welcome.
I'm a math student. Of course I know what 8 means. I'm a math student. Of course I know the Pythagoras theorem.
I'm a math student. Of course I love problems.
I'm a math student. Of course I use algebra in my everyday life. I'm a math student. Of course I know 100 digits of pi. 3.141 + 9, this is pi.
I'm a math student. Of course I love calculus.
I'm a math teacher. Of course I'm always at work.
We're in junior school. Of course we love math.
Hi, Tommy. Hi, Stu.
Hi, Kat. Hi, Cody. Wanna play a game? I'll flip this coin, and you guess either heads or tails.
Sure. I'll guess heads then.
Nope, you're wrong. It's tails.
No. You're cheating, Tommy.
No! Technically, he's not cheating because of probability.
What is probability?
Probability is the chance of something happening, or in other terms, probability is the measure of how likely an event is to occur. It is usually expressed as a number between 0 and 1, where, 0% means the event is impossible. 100% means the event is certain. Probability can be calculated by the formula. P event equals number of favorable outcomes over the number of possible outcomes. There are 3 types of probability: theoretical, experimental, and conditional, but we'll only be looking at theoretical. For this situation, theoretical probability is a way to predict how often something should happen in a perfect world, based on math. It does not depend on real-life experiments, just logic. For example, the coin we were playing with only has 2 sides, therefore, the theoretical probability of the coin landing on heads is The number of possible outcomes would equals 2, because the only possible outcomes are heads and tails, and the number of favorable outcomes would equals 1. Because the thing you want is heads, therefore, you only want one of the possible outcomes. Therefore, P, heads, equals 1 over 2, which equals 0.5. Which means there is a 50% chance of it landing on heads. And it means the game is fair. Tommy isn't cheating.
Oh, so that means that probability can be used in everyday life to predict outcomes, such as weather forecasts, winning a game, traffic delays, and medical test accuracy. It can help in decision making, from shopping deliveries to sports results, and even exam guessing.
Scientists in England say that pork fat good for you. And the best thing to fry in is the pork lard. I knew that ever since.
You can't eat with knife and fork.
That was spoil the taste. Smoked potatoes with a little fat from Clariton and Emerald City. Taste proper.
John is a father, a brother, a friend. His home is his pillar. It's where he finds strength. But life has a way of finding loose ends. And one day he lost hope when misfortune came. Then along came a promise of fortune to change. Fast, fair claim settlement and service that saves. So John and his family, with answers in tow, can look to the future with worry no more. CGI is here. Let's work it out.
Welcome back. The time in Barbados and the Eastern Caribbean is coming on to 2:30, and we are definitely in the home stretch and wrapping up International Day of Mathematics 2025, University of Waterford, also known as Combermere School. And Michael, I cannot think of a better way of wrapping this up, and I want you to do the honors of introducing this wonderful woman in our presence.
We have Miss Abigail Cumberbatch, Head of Mathematics, the person who spent a lot of time behind the scenes putting this together. So my first question to her would be, how do you feel about today?
I feel ecstatic. I think that's the best word. I am very happy with how it has gone. I'm happy with the involvement from everyone in the department, outside of the department. We had persons being involved. We have Mr. Brian, for example, music teacher, and the person behind the scenes. And he likes to stay behind the scenes, but he does awesome work there for us. We have Miss Nelson, who also assisted us today with our camera work. We have our camera ladies, Miss Waterman, Miss Ford, who couldn't be here today, but she did a lot of our interviews from prior. We even have our student volunteers in Drake's and Miss Doughty. So we have a whole lot of people being involved. We have the chemistry department, sociology and geography department, yourself as a physical education teacher. We have old scholar, Mr. David Strong. We have some of everyone getting involved, and I am really happy with the support and the involvement and the interest shown. And of course, we must celebrate our students. I am so pleased with the involvement of the students. They came out, they stepped up. So the posters, I can say, they just stepped up the quality of the posters, yes. The videos, the quality was much improved. And then we have our new competition, the Jingle competition. We had students trying to, work on their jingles and so on. So we had students getting involved. We added at the last stage a worry challenge.
Okay.
Based on the interest that was shown in Culture Day.
And that's happening now too?
Happening right now. So our students were like, they want to come back. So we say, you know what, we're going to add it in. And plus there is that element of problem solving and strategy involved there. So we have something for everybody. And I'm happy to see everyone finding their niche in terms of the areas that suit them and being able to show mathematics. And one thing I must say, the students, even in their posters and their videos, they not only show them mathematics, but then they try to show the application to real world and jobs and such like. So I don't know how else to describe it, but I'm feeling very elated, relieved that we are at the end because it has been a very long journey.
Yes.
And I am very, very thankful to all who are involved, and as well as the sponsors. The sponsors have been so gracious. I can't thank them enough. They have stepped up. It was easy in terms of reaching out for sponsorship. They were already ready and raring to go to assist, having assisted in the previous time. So I hope I didn't leave out anyone, but I am
They
pleased.
will forgive you. They will forgive you.
I am pleased with the involvement of everyone.
Abigail, it's showing you exuding that satisfaction. But really, how exhausted are you?
Oh, on a scale of 1 to 10, probably 100.
Yeah.
Yes, I am very exhausted, but in the end, I feel like it is worth it.
Correct.
Sometimes during, you kind of get ups and downs because things don't always go the way that you plan. So the final product isn't always what you started with. So sometimes you may have a concept that we're going to include X. We don't get X, but we get Y. So we had that kind of situation happening.
Michael and I were discussing things like that, when we were off camera, So it's actually, this is not new to us. But I also mentioned to Michael that he seemed to agree with me that maybe what we should do is have somebody following you guys around in the 3, 4, 5 weeks leading up to this, to let people actually have an appreciation of what really goes on to get something like this put together in 4 hours.
It is true. It is true. And I think that is something that people don't see.
I often say that.
You know, for them to follow us around, I believe they would be so exhausted. They would be like, you know what, I'm done with that. But because we have a vision of what we want to see in terms of mathematics education, we know that math is still inaccessible to too many people. Every time we have CXC results coming back, or we have common interest results coming back, there's always that public outcry that math is not doing as it's supposed to be doing. And it's not just in Barbados. If you look across the region, the CXC pass rate is also not one to shout about. And then if you go a little further internationally, because I like to follow what's happening internationally, so I get newsletters coming to my inbox on different strategies, different things people have been trying, different concerns, and you see that math education is a concern all over. And I believe that is a thing that we have to accept first as a problem, and then look at how we can try to mitigate that problem. A lot of it has to do with our mindset. And there's generations and generations of the idea that math is an elite subject. Only a few people can access it, can thrive in it. So we have to get past that. Because very often I remember when people ask me, what do you do? I always give a little snippet. I work, I teach. And they say, what? I say math because I know when they say math, the response I'm going to get 9 times out of 10 is like a very negative response because people have a negative experiences regarding math. Every once in a while you'll find somebody who's like, who love math, but that's very seldom. And people like to go back to their trauma with math.
They never remember the ups, always the
exactly,
downs.
always the downs. And we see that being transferred to our children. So sometimes when you have parent-teacher meetings, for example, and parents come in front of you and you try to explain where the students are at, sometimes they will admit that they too were not good at math. But I don't mind admitting that you were not good at math, but then sometimes it's an excuse for the students as well. So you kind of say, well, I wasn't good at it either. So it's almost excusing students' success or lack of success in mathematics. And I think that we need to get past that trauma, hold people's hands, present math in a different way so that it's more accessible to everyone, so they can see that it is really all what we need in life. Everything is about math. Everything is supported by math skills and math concepts. So if we can kind of demystify mathematics through events like this, hopefully then, maybe not in our lifetimes, but I mean hopefully yes, but hopefully if we continue to do things like this, we'll see that change where people are better able to, I would say, engage with mathematics and be successful and feel successful and feel that they enjoy it and appreciate it. So that's what this is all about.
I could identify with the thing about the days leading up to the event. People often see the event as a cheese on well put together. But if they know what goes on before you get there. And knowing Ms. Cambach as I do, all I know her mind is going in overdrive as to what she can do to make this better next time around.
This is great.
Because this happens to
Pressure
me.
is on, Michael.
No, this happens to me when I organize our sports meet. People come and say, good job. But I'm always thinking, because I'm my own biggest critic, right? And I think she's her own biggest critic also. So what I'm trying to say is that you don't ever be satisfied. You always strive to be better. And as I said, today, to me, has been much better than 2020.
Very, very better.
Much better. You know?
I agree with that 100%.
And I want to commend you on camera for a job well done. And if you're doing this again, I'm around, I would be willing to assist again.
Well, you got my commitment as well too.
I
And I think
appreciate
a lot of what you have said, Michael, you may agree with, has been sort of actually echoed by the principal earlier on. Because
Yes,
And
yes.
it's really good
Yeah.
because he obviously has the exact view of you and the demystification
Yes.
of mathematics and the application in everyday life. And I think that we're on the right track. People like yourself and the principal and your staff. I mean, nothing too great can be said about what they have done to make this a success. So Abigail, let me also congratulate you and your staff members and those behind the scenes, John, and all those who put this thing together, the student participation and the level of their inputs. Exemplary.
Yes, and let me also, a special thank you to my department. They were all in. You saw them all over the place today. We interviewed quite a few. You had Miss Pemberton created her own video that we ran a couple of times. We were able to get Miss Hayward in here. We interviewed Mr. Rollins. We had Mr. Wiggins interviewed last week because we knew we were not going to be here this week. So we had in the entire department being involved. And even those that I did not mention, I'm not leaving you out, but I appreciate all of the work because they were all in the different classes all over the place trying to make sure that everything ran smoothly. And from what I saw, all the events came off quite nicely. So a special thank you to the mathematics department and all the other departments who got involved.
So in essence, another team Combermere production.
Another team Combermere production.
Well done, all. And Michael, I can say this before you jump in before me. It has been an absolute pleasure of mine working with you again, and I hope to do this until such time as there's no breath in our body, my friend.
The feeling
Thank
is
you
likewise.
very much.
Likewise.
Indeed. Thank you.
And I thank you as well. I really do enjoy you all doing this here for me. I appreciate it, and you will be back.
Thank you.
So just be on your awares.
Yes.
And we can't finish this without thanking Mr. Bryan.
Mr. John Bryan.
Mr. Bryan.
I think that we need to recognize Mr. Bryan. I don't know if we can get him in here.
I think we should bring. I think we should
I
bring
don't know
him
if
in
you
here.
can pressure Mr. John Bryan to come and
John
show
Bryan
his
should
face.
be
He
in
would
here.
probably say, no, is Mr. John Bryan?
John
Would
Bryan.
he show his face on camera or not?
Can you come in here, please? You've been summoned. That's not a request.
He has to come.
He's not answering me.
He's not coming.
So we will have to arrange a set.
We have to arrange a special session.
Mr. Bryan,
Mr. John Bryan.
Mr. Bryan, look, we do here, look. Oh, Mr. Bryan, he's not answering me.
No, he's not.
I think it's fitting.
Mr. Bryan has
Mr.
sent
Bryan
his
should be
signal.
here.
He sent the signal that he's not going to join us.
He's not going to join us.
You know, because he does have an image to uphold, and he wants to make sure of that. I'm going to probably sing him a song after him.
No, I want to. I've said it. I've said it a lot, but I want to hammer it home. The thing I love about Combermere is that when Combermere teachers need to step up, they step up. I've heard a lot of talk about nothing going on at Combermere.
Are you
this
kidding me?
Today would knock that so-called theory out of the water.
Oh, Michael, I told you
So-
the other day when we met that every time I pass the school morning doing like this activity going on. You can't,
Yes,
you
yes,
are the first to get here and students are here.
yes.
You leave late and students
are here.
This
Right?
school is a hive of
So
activity.
John not coming here, I can understand him being camera shy, but John has done a tremendous
He
job.
has been the man to keep
Right?
it together.
We must give credit where it's due.
Absolutely.
And John, although you're not here, I want you to know that I have a lot of respect for you.
We all do, sir.
And one of these days you will find yourself in front of the camera. Trust me, I will find a way to do that.
Thank you very much, all. This is where we conclude this year's International Day of Mathematics 2025. And from the studios of Waterford University, also known as Combermere School, we bid you adieu.
Kite